As you know, all the continents on Earth have different climates, ecosystems, and cultures. But it wasn't always like this. In fact, this will also change in the future. Someday, our world will change beyond recognition. All continents will become one great land. What will it look like? Well, I won't be around for this, but let's find out, shall we? Let's peek at the world map. There are 7 continents: North and South America, Africa, Australia, Antarctica, Europe, and Asia. If you know this, congrats! You still remember something from elementary school. Now, have you ever noticed that their borders line up quite well with each other? For example, South America and Africa look just like 2 puzzle pieces. The scientist Alfred Wegener also noticed this back in the 1910s. After finding this out, he continued to assemble the puzzle and noticed that India and Madagascar line up with Africa just as well. But that wasn't the only strange thing about the world. For example, we found the fossils of the same ancient animals on completely different continents. Now, how's that possible? They couldn't have originated as a species in Japan and Central America at the same time. That's just preposterous, a special word I like to deploy now and then. Could some of them have crossed the ocean? That's unlikely, unless they're some kind of Olympic swimmers. Maybe there used to be some kind of natural bridge between these continents. But even though so much time has passed, if it really existed, we would have found traces of this bridge. And what kind of crazy builder would build a road that long? There were a few other strange things. For example, people found traces of the same mountains both in the US and in Scandinavia. What does it all mean? Wegener thought hard about it, and then it dawned on him. A brilliant discovery. In 1912, he presented his idea to the world. The general idea was that the continents move like icebergs on water. They're constantly converging and diverging. Now, we know that he was 100% right, but unfortunately, scientists at that time basically pelted Wegener with tomatoes. He lacked data and couldn't explain exactly how these plates move. Nevertheless, Wegener didn't give up. He wrote a book called The Origin of Continents. And finally, in the 1930s, the geologist Arthur Holmes filled in the blanks in Wegener's theory. Finally, the world... we'll have to wait another couple of decades until the world realizes that this is true. People are kind of slow, huh? Anyway, now we call it the theory of continental drift. By the way, on a grammatical note, when we travel on a continent away from the beach to farther inland, we say we're going inland, rather than we're going incontinent. Big difference, don't mix them up. Meanwhile, the continents on Earth move along the mantle by several inches per year. Every few million years, they bump into each other and create the so-called supercontinents. Supercontinents are, as you might have guessed, huge land masses that consist of several smaller continents. We're still not sure how many of them existed before, but you've probably heard about one of them. It became the most famous because scientists believe that it was the only supercontinent in the history of the Earth. It was named Pangaea because Afro-Arctica Euro-Aussie-Amerasia is too long to remember. Hey, just kidding. Pangaea from Greek means the entire Earth. Beautiful, right? This supercontinent existed for about 160 million years, but it broke up a very long time ago. That's why it's hard to even imagine what Pangaea looked like and how many things have changed on it. It was significantly different from our present Earth. For example, there weren't any mountain ranges that we have today. The CO2 concentration was 5 times higher than it is now, so the average temperature was much warmer. It's possible there wasn't even ice on Earth, only tropical forests. This Earth could be a greenhouse, and even the North Pole could be covered with rainforest. Sounds like a pleasant place. Dinosaurs witnessed all this, but we didn't. The first humans appeared only 2 million years ago, and the first Homo sapiens, which is basically us, appeared only 300,000 years ago. So, unfortunately, we as a species basically missed the cool continental drift part. But maybe one day, we'll be able to see what it could look like. You see, Pangaea wasn't actually the first supercontinent. There were at least 3 of them before it. The oldest one, Valbera, existed about 3.6 billion years ago. It became the grandma of all the continents we know today. Valbara included almost all of them. Then it broke up, like a couple on a bad date, and we got her grandkids, Ur, Kinnerland, Nuna, and so on. Eventually, it came to Pangaea. Now we know that they form every 600 million years. That's called the supercontinent cycle. That means one day on Earth, everything will merge together again. But when and how will it happen? Well, first of all, we need to clarify something. We have one supercontinent, right? Basically, one huge island. That means the rest of the world is now a superocean, except for a couple of small islands, maybe. The ocean at the time of Pangaea was called Panthalassa, and our cool, mysterious Pacific Ocean is actually just its pathetic remnants. The other two big oceans, the Atlantic and Indian ones, were born when Pangaea started to break into separate pieces. So when these oceans close, completely drying up, new supercontinents are formed. And every time they close gradually and very slowly. It means that the Pacific Ocean is shrinking in size right now. Yep, it loses a few inches a year. Boy, I could sure lose a few inches a year. Now, it's hard to imagine, but in the future, it will become an ordinary puddle. It will disappear together with the Arctic Ocean, and that's inevitable. But when it happens, a new supercontinent will appear, Amasia. The birth of Amasia was predicted by scientists from the University of New Curtin in Australia. They did some very complex calculations on a supercomputer. They uploaded the continental movements of the last 300 million years or so. And then, based on these calculations, the computer predicted what the future holds for us. We learned that one day, the Americas, both South and North, will collide with Asia. And this collision will create a new supercontinent with a very original name. As already mentioned, the Pacific Ocean will one day completely disappear. On the other hand, the Atlantic Ocean is growing right now, pushing both Americas to the west. So when Amasia appears, this ocean may become the new largest ocean in the world. So here's what it's going to look like. Both Americas will collide with East Asia, and although it's hard to predict, some sources claim that Antarctica eventually will find its way to South America. Australia will also play a huge role in this. It may connect America and Asia. So, it won't be down under anymore? Guess not. And if humanity somehow still exists, that means that you could hike from France to Australia or from South Africa to Argentina without getting your feet wet. So, here's a solution. If you can't travel right now, just wait 300 million years. And no, that doesn't count the wait time getting through airport security. Scientists also used to think that Amasia would gather around the North Pole, creating a huge ice cap and cooling the planet. However, now they think that this is very unlikely. It's probably going to be somewhere in the middle of the poles. However, this doesn't mean that the Earth will remain as friendly as it is right now. The Earth of the future will be radically different from what we know. The sea level will become lower, and the Amasia will consist of vast, very arid areas with high daily temperature ranges. Yep, it's going to be super hot. The ecosystem will completely change, but it's quite difficult to say what it will all lead to. The more data we receive over time, the more accurately we can predict the future of our planet. At the moment, all these are just theories, and scientists note they're still far from being proven. But even so, the results of the team's work are very impressive. They tell us a lot not only about the future of the planet, but also about its past. Wouldn't it be great if humans could live up to those times? We could watch from distant space how our home planet is changing. It's fascinating and a little bizarre at the same time. Surprise! There's more than 7 continents on our planet. Argoland, a hidden continent, may help us understand how our planet will look in the future. To find out how it hid from us and what secrets it holds, well, you'll just have to keep watching. Ready for a mystery? Scientists have been looking for a piece of land that's been missing for over 100 million years. Not exactly newsworthy, since people search for information about our planet's history all the time. You'd think it was probably this minuscule island somewhere in the middle of an ocean. Well, you'd be wrong, because this continent used to be as big as the entire U.S. territory. For a long time, geologists have been wondering whether a massive chunk of contemporary Australia vanished into thin air. Some believed it was simply hiding somewhere on the ocean floor. But thanks to some Dutch specialists and 7 years of investigating, we now know there are bits and pieces of this lost land mixed underneath the lush jungles of Southeast Asia. The continents we see in our geography manuals these days are like scattered pieces of a puzzle. There's even a nice experiment you can conduct to see for yourself. Find a world map online and print it out. Cut out all of the continents and play around with them for a while. You'll see they all fit together. Probably the most striking thing you'll see is how South America perfectly fits near Africa. If you close up the oceans that were formed in the last 200 million years, the continents look like they form a giant letter C. And that C is what scientists call the supercontinent Pangaea. It was swimming in an ocean called Panthalassa, and the inner portion of that letter C had a smaller stretch of water called the Tethys Ocean. It is in this small ocean where things get interesting. Back in the Jurassic period, this vanished continent, which scientists started calling Argoland, vanished and left a hole in Australia, now known as the Argo-Abyssal Plain. Geologists initially believed this was all due to a process called subduction. It's when one piece of the Earth's crust dives under another and recycles it into the planet's mantle. Usually, specialists track this continental vanishing through off-scraping. That's how they figured out, for instance, that India bumped into Asia and gave us the majestic Himalayan mountains. But for Argoland, things were a bit more complicated. Bits and pieces were popping up in places like Myanmar and Indonesia, but they behaved like these time-traveling relics, looking way older than when Argoland supposedly separated from Australia. It immediately raised the question, if one continent can behave so weirdly, how many others are out there doing the same? Thankfully, scientists have now put together the entire timeline of Argoland and figured out its mystery. It didn't sink or get swallowed up. It simply transformed into an archipelago, breaking into smaller pieces, called microcontinents, and floating away from Australia. These mini-continents then took a little journey before settling down in Southeast Asian jungles. This discovery fits right into the whole Pangaea puzzle. It helps us better understand how continents break up and make up, all in one discovery, revealing secrets of biodiversity and climate back from in the day. If you'd like to find out more secrets about history, civilization, or random day-to-day objects, be sure to like this video and subscribe to the channel. Like, for instance, the mystery behind this invisible species line in Indonesia. It's called the Wallace Line, named after the British explorer Alfred Russel Wallace. Over 150 years ago, Wallace was on a journey around the Malay archipelago, visiting thousands of islands. What he found was that animals on one side of this invisible line were considerably different from ones on the other side. This invisible line is like a wall between marsupials and tigers, for instance, or honey-eaters and trogons. But now we know that around 35 million years ago, Australia broke up with Antarctica and collided with Asia, and this continental love triangle triggered significant changes. It didn't just change the way the land looked, it also messed with the species of animals on each side of the Wallace Line. In more recent times, a bunch of specialists published a study saying this collision and climate chaos made Asian species comfy living in the Malay archipelago. Meanwhile, the Aussie animals weren't as happy with the new environment. It was too hot and wet for some, and others just couldn't handle the tropical island lifestyle. The discovery of this continental shift towards Asia might also explain a recent finding of a human species that didn't seem to make any sense either. You see, in this hidden cave in the Philippines, archaeologists stumbled upon a new human ancestor. It seems that about 50,000 years ago, on the island of Luzon, there was this ancient human-like species. The lead researcher believed this finding was crucial for understanding human evolution in Asia, and it named this new species after the island, Homo luzonensis. Now, here's where it gets a bit confusing. The bones found by archaeologists had one small problem. They had a weird mix of traits that hadn't been seen together in any other hominid species. Smaller teeth, similar to ours, yet hands and feet that were more like our ancient humanoid ancestors. It was those throwback limbs in particular that connected this human species with the long-lost southern territory. That's because they have this primitive look, like these hard-to-pronounce guys, for instance. Only these two species are separated by 2 to 3 million years of time in evolution. Many have wondered, is Homo luzonensis really a new species? Not everyone is convinced. But it may also explain why living creatures are also affected by the constant shifting of the land underneath us. Now, just because they haven't changed much during our lifetime, it doesn't mean our continents will look like this forever. They evolved from this large megacontinent, and they'll most likely end up in a similar position in the future. On that note, a geologist from a European university tried to predict the future of Earth's supercontinents. As a starting point, he used an earthquake that occurred in Portugal back in 1755, when tectonic plates behaved a bit differently than they should have. After years of research, he came up with a theory in 2016. He believed that the stitches between these tectonic plates might be coming apart, setting the stage for a bigger rupture. It's like when glass cracks between two holes in a car windshield. If this happens, a subduction zone could stretch from the Mediterranean all the way up past Ireland, bringing volcanoes, earthquakes, and new mountains to these areas. If all goes according to this plan, the Atlantic Ocean will disappear, and so will the Pacific, turning into one large stretch of water. Instead of the 7 continents we know today, we'll get a new supercontinent, which he called Arica, because it would have Australia and the Americas at its heart. Now, it's not the only possible scenario, though. Novo Pangea might be another, and it's easy to foresee. The Atlantic stays open and the Pacific closes. Then there's Amasia. For this one, you'd have to imagine the Arctic Ocean closing and the Atlantic and Pacific staying open. Everything shifts to the north around the North Pole, except Antarctica. One final scenario would be called Pangea Ultima. Slow down the spreading in the Atlantic, and a new subduction plate pops up on the America's east coast. Well, either way, if all the continents collide in the future once more, some say it won't be fun to experience. It's believed that in around 250 million years, we'll feel like we're being trapped in a sweltering, soggy plastic bag. Weirdly, that bag will be the best place to live on Earth, the coastal areas. As for the inland spots, they'll be sizzling, like a desert on fire. Many of the species of animals we know today might not make it. As for us humans, we'll need to be creative if we want to withstand the heat. We should be thankful, though. These digital models are still great because we can use them to test all sorts of interesting ideas. For example, how these supercontinents would mess with tides. Taking future space travels into consideration, these models can help us understand the climates of exoplanets too. Those are located outside our solar system. Sandy Island is a creepy landmass that appeared on world maps for nearly 200 years before vanishing into thin air. Located in the South Pacific between Australia and New Caledonia, this phantom island was first documented by explorers in the 18th century and continued to pop up on maps and even scientific surveys. But when a research ship sailed through its supposed coordinates in 2012, they found nothing but open water. They even measured the ocean depth at this spot, and it was always more than 4,000 feet deep, so there was no chance of a big piece of land could be hiding under the water. To make things even weirder, when you look up its exact coordinates on Google Earth, you'll still see a faint outline of what looks like a long, thin island, but with no landmass in sight. Theories about its disappearance talk about possible cartography errors, but the mystery of how a whole island fooled the world for centuries is still unsolved. Now, speaking of mysterious islands, let's dive into the enigma of Hashima Island. Located off the coast of Nagasaki, Japan, This small island was once a bustling coal mining facility, thriving with workers and families, but as the demand for coal declined, the island was abandoned in the 1970s, leaving behind a haunting ghost town. Today Hashima stands eerily silent, with crumbling concrete buildings and overgrown vegetation. And if you are brave enough, you can do a virtual tour using Google Earth. But there are other places where digital maps won't let you see much, like the Ward Islands in Australia. If you search for its coordinates, you'll notice a bunch of blackout spots near the coast. This has led to all sorts of wild speculation online, sparking curiosity about what might be hidden beneath the surface. I mean, is it just a glitch? Or could there really be some unusual wildlife down there? Well, we still don't have concrete answers for these obscured areas, but it is worth mentioning that this region is part of a wilderness protection area. This place is an important zone for the Australian sea lion and the New Zealand fur seal, for example. So, these blackout spots could be just part of a plan to keep everything private and protected out there. From creepy islands to abandoned places, if you ever find yourself driving through Rio de Janeiro, you might catch a glimpse of something unsettling: a group of creepy Santas, faded candy canes, and rusty slides surrounded by palm trees and dense greenery. This is Parque Aba Noel, an eerie, abandoned Christmas-themed amusement park in Brazil. The park's creator had big dreams, thinking it would become a massive, eclectic attraction with different themed areas. We're talking about a space the size of 460 football fields. Work started in 2000, but the place shut down a few years later after the creator tragically passed away in a car accident just meters from the park's entrance. Today, the attractions are slowly being taken over by rust. This totally feels like something out of a sci-fi movie, but those multicolored rings are actually right here on Earth, in Yellowstone National Park to be exact. At 370 feet in diameter, it is the largest hot spring in the United States and the third largest in the world. When you see it from above, the different colors come from various types of bacteria that act like real-life thermographic filters. Each type of bacteria thrives at different temperatures, and their colors reflect the heat levels in different parts of the spring. Our next stop is in Italy, where you can find the Villa de Vecchi, also known as the Red House or the Ghost Mansion. For every ghost mansion, there's an urban legend behind it. Now, while nothing we're about to say is confirmed, the tale is still pretty interesting and downright bizarre. Built in the mid-19th century by Count Felix de Vecchi, this once grand summer residence quickly became the site of tragedy. The Count's wife passed away under mysterious circumstances, and his daughter disappeared, never to be seen again. Devastated, the Count is said to have spent his remaining days searching for answers. Over the years, the mansion fell into ruin, with local legends adding to its haunted reputation. Some claim to hear strange noises or see ghostly figures, while others whisper about unusual rituals that might have taken place there. Though crumbling and overgrown, Villa de Vecchi remains popular for those intrigued by its eerie history. While we've explored eerie and abandoned human-made structures, let's take a look at a place where nature's forces left their own massive mark: the Meteor Crater in Arizona. The site was formed in an instant about 50,000 years ago, when a large iron-nickel meteorite slammed into Earth. Measuring just under a mile wide and 560 feet deep, the crater is one of the best-preserved impact sites in the world. Standing at its edge, you can almost picture the incredible force of the impact, wiping out everything around it. Today, the meteor crater is a fascinating geological landmark, drawing in scientists and curious visitors. From a Google Earth point of view, this area in Niger looks creepy, and what seems to be clusters of glass domes dotting the landscape, almost like an interplanetary colony. But in reality, it's kind of an illusion. Those domes are actually small semicircular pits, and they're part of the Just Dig It project. Can you dig it? These pits, known as water buns or earth smiles, are dug to capture rainwater and restore dry, degraded land. It's a simple but genius method, that helps bring life back to areas suffering from desertification. By trapping water, these buns allow vegetation to grow again, cooling the land and reviving ecosystems. Now, you have probably heard of the famous Nazca lines in Peru, right? We're talking about those massive ancient geoglyphs carved into the desert, which have shapes like a spider, a monkey, and a hummingbird. Well, recently, something similar popped up, and it's got the internet buzzing. This new figure, located at the top of a mountain, looks a lot like a wild boar. While it's super cool to find a potential new geoglyph, the lack of solid info and the not-so-sharp edges make us think it's just a natural formation. It's still pretty intriguing, though. But if you head down south to Chile, that's where you'll actually find a real geoglyph. We're talking about the Atacama Giant, which is around 390 feet tall. What looks like a funny drawing seems to represent some sort of spiritual figure or deity. There's no solid proof of what it actually means, but experts believe this design might have worked as an early astronomical calendar. The points on the top and sides of the head are said to indicate the seasons based on how they align with the moon. Meanwhile, you might also find some mysterious shipwrecks while exploring Google Earth, like the MV Plassey in Ireland. This ship met its tragic fate back in 1960, when a heavy storm and strong winds blew it ashore at Finnis Rock, tearing a hole in the vessel's bottom. Water started rushing in from underneath. After some shouting and running in all directions, the crew managed to get out of the ship. Today, the vessel's remains are still at Finnis Rock and have become a popular attraction. You can still see its hull, which keeps falling apart over time, making the whole scene even creepier. And we've also got something interesting involving the Titanic. Now, it's true that the ship is really 13,000 feet underwater, so you actually can't see it with satellite cameras. But if you type these coordinates into Google Earth, you'll find the spot of the Titanic accident. It's not that creepy of a place. I mean, it's really just a huge expanse of blue. But still, it's pretty interesting to get the big picture of how they seem so far from everything on that tragic night when the ship went down. Consider South America and Africa. Don't they kind of look like they fit together, like puzzle pieces? Well, they actually did. But about 130 million years ago, South America was like, bye, and slowly started drifting away. These days, it's around 1,800 miles from Africa, and it's still on the move. Every year, the continent shifts a little more toward the Pacific Ocean. So, how's that even happening? Tectonic plates are constantly moving. That's what makes the Earth's surface shift over time, going from this to what we see today. But those movements happen so slowly that you and I can't see them go. So, no, Brazilians or Chileans aren't out there feeling their continent inching westward. But the numbers don't lie. South America is moving, and apparently all it wants is to get as far away as possible from this massive underwater mountain range called the Mid-Atlantic Ridge. But what exactly is pushing the land toward the Pacific Ocean? It is the heat inside our planet. Way down beneath the ocean, there are cracks in the Earth's crust, and magma, super hot melted rock, rises up through those cracks. When that happens, the magma cools and hardens into solid rock. Over time, this process might build underwater mountains, like the Mid-Atlantic Ridge. And as more new crust forms, it begins to push the older crust out of the way. In the process, tectonic plates and the continents riding on top of them get pushed along. Now, on the other side of South America, over by the Pacific, there is the Nazca Plate. It's heavier and it's moving eastward. Since it is denser, it is sliding underneath the South American plate. This entire process is called subduction, and it's happening at a rate of about 3 inches per year. By the way, the collision between these two plates is what's behind all those breathtaking volcanoes scattered throughout the Andes, and it's also making the continent move. So, if everything goes according to plan, projections show that South America will end up more centered in the Pacific Ocean in the future. But some models suggest something way crazier. Before we get into that, though, we need to clear something up. Why on earth isn't Africa following in South America's footsteps? I mean, shouldn't it be drifting west too? Well, not quite. Africa is doing its own thing because it sits on the African plate. So the mid-Atlantic ridge is located between those two continents, and just like it pushes the South American plate, it also pushes the African plate, but in the opposite direction. It's like this ridge is trying to split up two ex-besties, you know? But there's more. Africa is also being influenced by the East African Rift. That's one of those massive cracks we talked about earlier, but it's happening on land, which makes it extra dramatic. This is what's causing the continent to slowly split apart. It's a long story, but let's just say the rift is pulling Africa in more directions than South America ever had to deal with. Okay, now it is finally time to talk about that crazier thing that might happen to South America and everything around it in the future. Theory number 1. It could break away from North America. I know, super dramatic, but don't panic. We're talking hundreds of millions of years from now, and I won't be around. You see, both continents are moving in the same general direction, but at different speeds. The North American plate is cruising along at about 1 inch per year, while South America is moving a bit faster. So even though they're heading the same way, they are not keeping pace. Over time, as the Atlantic Ocean continues to widen and the Pacific keeps shrinking, all this tectonic movement could eventually pull the Americas apart. Theory number 2. Marine life could go through some major changes. Right now, the Americas act as kind of a giant wall between the Atlantic and Pacific Oceans. Because of that, sea animals have evolved differently on each side. Take the green sea turtle, for example. The ones living in the Atlantic tend to be bigger and lighter in color. Meanwhile, their Pacific cousins are usually smaller and darker. But if, one day, there is no land blocking these two populations from mixing, they would end up with brand new migration routes, new nesting spots, and a lot more overlap in their territories. Now, multiply that scenario by hundreds of other species, and things could really get shaken up. We're talking about new interactions, unexpected competition, and maybe even the rise of entirely new species. Alright, theory number 3. America might meet Africa again. Right now, the Mid-Atlantic Ridge is busy creating a new seafloor, and because of that, the Atlantic Ocean is slowly getting wider. But in about 125 million years, scientists believe that process could come to a stop. Instead of the seafloor spreading apart, the ocean floor might start getting pulled under the continents. When that happens, the Atlantic will stop growing and start shrinking. And the water section between South America and Africa is likely to be the first part pulled beneath the land. That means the Americas and Africa could meet again. And when that happens, border countries could turn into super shaky places, with earthquakes happening all the time and brand new volcanoes popping up left and right. The eastern United States would no longer be known for the peaceful green slopes of the Appalachians, but for snow-covered giants that occasionally spew lava and ash, more like the Cascade Range out west. Countries would end up with totally new neighbors. Brazil might line up with Nigeria and Cameroon. Uruguay could be sitting right next to Angola. And Argentina might be sharing a border with South Africa. So if these two continents really do merge, how intense would that be? Well, for starters, this new supercontinent would instantly become the biggest one on Earth, about 1.5 times the size of Asia. And chances are, a brand new mountain range would form right where the continents meet, creating a natural border between nations. Being part of the same massive continent could make a lot of things way easier. For one, tourism could totally take off. People traveling between countries by land without needing pricey plane tickets could be a game changer. But it wouldn't stop there. Other types of economic activity could get a major boost too. Now on one side we have South America, which already produces and sells a wide variety of foods, from wheat to bananas, beef, cocoa, soybeans, hey, you name it. On the other side, there is Africa, exporting things like textiles and clothing. That alone would make them a super powerful bloc when it comes to trading raw goods. But can you name another important thing these two continents have in common? Yep, petroleum. Countries in South America, like Brazil, Venezuela, and Colombia, are major oil exporters. And over in Africa, you've got Nigeria, Algeria, and Libya doing the same. Now, can you see just how powerful that kind of union could be? Meanwhile, let's talk about animals. These two massive lands coming together could lead us to wild meetups, like a capybara sharing space with a Nile crocodile, or a sloth seeing a hyena from the top of a tree. This could even lead to new animal hybrids showing up, like a tabby crocodile or a sloth hyena. Okay, those weren't the cleverest names, and honestly, these animals wouldn't be able to mate or even wouldn't want to. But you get the point, right? It's not all positive, unfortunately. New species showing up could become predators, competitors, or even parasites to the native plants and animals. It would take a long time for things to settle into a new balance in those border regions. But honestly, no one really knows how long it would take. The only thing I do know is neither of us will be around to see it, which is okay. Now, at first glance, it seems like we're on a giant raft called a continent that's just floating around on some molten lava until it hits another continent. Okay, let's make a quick stop at high school science class. Our home planet is like a cake with different layers of ingredients stacked up on top of each other. The Earth's core, mantle, and crust. Hey, where's the frosting? The cake batter on top represents the crust of the Earth, made up of 3 types of tasty rock: igneous, sedimentary, and, say it with me, metamorphic. These rocks are formed in different ways, such as from solidified lava or from the deposits of particles and minerals. The crust is what we stand on, a home to our continents, oceans, and everything we see around us. Then you have the mantle, not the baseball player, the layer that lies right below the crust. Many people think that the mantle is just lava, but it's not quite like that. Just like how you mix different ingredients in the cake batter, the mantle is made up of different types of rocks that are constantly moving and shifting. And finally, we get to the sweetest part of the cake, the center, or in the case of Earth, the core. It has 2 parts, the outer and inner core. The outer core is made of molten rocks and metals that are incredibly hot, even hotter than the surface of the sun. The inner core is solid, even though temperatures there are crazy. It doesn't turn into liquid because the pressure down there is amazingly strong. When you see all this, you can easily think that below us there are endless miles of lava and hot rocks. So, how come tectonic plates move at all? The continents don't float on a sea of molten rock. The oceanic and continental crusts really sit on a mantle. Sure, there's a layer of liquid rock in our planet, the outer core, around 1,800 miles below the surface, but it's separated from the surface by the mantle that's thick and solid. So, the Earth's tectonic plates move around because they're on a thick layer of solid rock, the upper mantle. Basically, this rock is under incredible pressure and heat, which makes it flow in slow motion over time. Think of it like honey or syrup that you pour over your cake layers. As you move the cake around, the honey or syrup will also move and flow. Similarly, the upper mantle can flow and drag the parts above it along, just way slower than honey. And the rock is both breakable and flexible. It can crack and break like a cookie, now I'm getting hungry, but it can also stretch and bend like a piece of taffy. When the plates get caught on each other, they can't move anymore. But when they break free, they start drifting again, like puzzle pieces shifting around until they find their perfect fit. Extremely high temperatures and pressure are the reason this flow happens. It's like a big pot of soup on the stove. As the soup heats up, it starts to move around, carrying heat from one spot to another. Is it lunchtime? And speaking of lava, it's not just molten rocks that travel all the way up from the outer core to volcanoes. When tectonic plates come together and one slides underneath the other, they create a lot of heat and pressure while grinding against each other. It's like rubbing your hands together fast and they start to get hot, or when you start a fire with rocks. And as the melted rock, or magma, rises to the surface, it can create volcanoes. Now, long ago, the Earth's land was not divided into continents as it is today. Instead, there was one giant landmass known as Pangaea, meaning all Earth in Greek. Whoa! Imagine being stuck in the middle of this giant ocean. So, over time, this supercontinent slowly broke apart. Its parts drifted away from each other and formed the separate lands we call continents. This idea first popped out in the 16th century when one cartographer realized the coastlines of Africa, America, and Europe appear like they could fit together like puzzle pieces. Later, researchers realized the rock composition of their coastlines was similar, which means they used to be part of one giant mass, and they call that the theory of continental drift. At first, people were pretty skeptical about that idea because they didn't know how such massive lands could move around. Now, we'd all be able to explain that part, right? So, the Earth's crust is divided into a couple of large plates and many smaller ones. All of them are still moving, even though it's in slow motion. We can't sense it, and we won't see any particular changes during our lifetime. It's a process that lasts hundreds of millions of years. As the plates move, they interact with one another in fascinating ways. For example, when two plates collide, one may be forced beneath the other, which would help create a subduction zone. Over time, this is the way you get many cool things like volcanic islands, trenches, and even entire mountain ranges. Plates apparently started moving around 3.5 billion years ago. It took them a while to group into the first jigsaw supercontinent we know about called Ur. Today, its remains make up parts of Madagascar, India, and Australia. Pangaea formed 335 million years ago, but it probably won't be the last continent that will form. So, some new generations in the distant future could live on something called the next Pangaea. When the oceanic crust of the Atlantic Ocean slowly takes its place under the continental crust, the oceanic basin of the Atlantic is going to close, which is why the continents will end up pulled together. This means the Americas will meet Africa, and Eurasia will be flipped on its side. So, people might live on a giant landmass in the shape of a ring, clustered around the inner sea, or at least what's left of it. Or maybe continents will take another direction and make up a different jigsaw puzzle called Amasia. In this scenario, the Americans will drift westward, fuse with Australia, and pivot to around Siberia. And then there's more. Novo-Pangaea is the option where the Americas swing together to embrace Antarctica and Australia, and Africa legs off to the northwest. Basically, all continents here get together to form a giant landmass that stretches from one pole to the other. Ready for one more? Nah, come on. A recent projection called Eureka gives an idea similar to Novo-Pangaea. It's just that all continents here unite to become one gigantic land that clusters around the equator. Maybe this would be my favorite one to live at, with the sunny weather and the beach all the time. And who knows what kind of magnificent trenches, mountains, islands, and other geological beauties we'd get with this giant supercontinent. Pangaea broke up about 175 million years ago. As the Atlantic and Indian Oceans began to widen towards the east, the Ring of Fire was formed. It's a path that goes along the Pacific Ocean with so many frequent earthquakes and active volcanoes. This way, Eurasia was unable to cross this border and continue moving westward. And now Eurasia could move laterally along the Ring of Fire. The subduction zones kind of act like a barrier that forces the tectonic plates to move in different directions. So Eurasia could eventually collide with the Americas and form something similar to Amasia. It would be cool to sit there, grab the popcorn, and watch it from the side. But this is something that won't happen for the next 50 million years at least. I'm willing to bet I probably won't be here to see it. Different theories talk about different positions where this new supercontinent might end up one day. But it seems it will probably be somewhere in the polar area, centered on what we today recognize as the Arctic Ocean. Not my cup of tea. Bring me back the sunny one. Wait, scratch that. Let's go eat.
See how the Antarctic Peninsula looks just like South America, but upside down? This isn't just a coincidence. It's the ghost of a 30-million-year-old breakup. These continents were once connected, but their divorce gave birth to an ocean current so powerful it was capable of completely freezing Antarctica and shaping its landscape. Here's how it went down. Tectonic plates pulled a sneaky move and cracked open a ridiculously narrow passage in the ocean, about only 500 miles wide, forcing 4.5 trillion cubic feet of water to flow inside this geological straw. This was the birth of an ocean current stronger than the Amazon River. This ocean current, called the Antarctic Circumpolar Current, by the way, flows in a circular motion, going clockwise because of the strong winds that blow over there. This circular motion around Antarctica caused erosion, shaping the landmass of the continent into a circle, except for that stubborn peninsula, which is being slowly dragged east like a kid refusing to leave a playground. Wait, South America and Antarctica used to be one? Yep, a long time ago. South America, Australia, and Antarctica were all part of a supercontinent called Gondwana, which also included Africa at some point. Back then, South America and Antarctica used to be basically joined at the hip by a land bridge called the Antarctic Land Bridge, which just so happened to be a lush green forest and also a great dinosaur highway. Yeah, you heard it right. Dinosaurs. A 95-million-year-old dino, whose name I can't pronounce, sorry, was discovered in Australia, and scientists found out it had actually been a distant cousin of Argentina's Sarmientosaurus. Same jaw, same chisel teeth, same everything. These guys were like identical twins, separated by an ocean. How? Because back then, Antarctica wasn't a frozen wasteland. It was a temperate rainforest, like Oregon, making it a pretty nice travel route for a dino family. But the land bridge wasn't just for dinosaurs. About 40 million years ago, the ancestors of Australia's marsupials waddled to the land down under all the way from South America, taking the Antarctica route, another proof that these continents used to be connected. Things remained somewhat peaceful for the dinos and the marsupials until Earth's ground started moving. This is what a German scientist called the continental drift theory, back in 1912. Our German friend here basically looked at the coast of South America and went, "Hey, this looks like it could fit into the coast of Africa." Like a scientific Sherlock Holmes, he noticed what others had overlooked for centuries. The continents were clearly pieces of a larger puzzle. And he was right. Here's the deal. Planet Earth is made of many layers of rocks and metals, like a cosmic onion. The outermost layer, the lithosphere, is divided into pretty solid tectonic plates that move atop a layer of softer, somewhat molten rocks, like slippery ice. This is why the plates move. In fact, they've been rearranging Earth's face for billions of years, with supercontinents forming and breaking apart in cycles, like a slow-motion game of bumper cars. This movement might be pretty slow since most tectonic plates only move 0 to 3.9 inches every year, except for the Nazca plate, racing ahead at 7.8 inches, about as fast as your hair grows. But don't let their snail's pace fool you. These shifting slabs are the ultimate planet shapers. Their slow dance gives us everything from earthquakes that build mountains like the Himalayas, to rifts that birth oceans like the Atlantic. All because the oceanic crust is dense and sinks like a stone, while continental crust floats like a cork. It's this density difference that explains why continents exist at all. Without it, Earth would be completely covered by shallow seas. This slow-motion planetary renovation project is exactly what tore South America and Antarctica apart 30 million years ago. The plates under these continents started to drift apart in a process called crustal extension. It's like the lithosphere was pizza dough being slowly stretched until it thins and splits. As the crust stretched, it became thinner and weaker, eventually cracking like the surface of a drying lake bed. This whole thing gave birth to a new tectonic plate, the Scotia Plate, that emerged between South America and Antarctica, like a geological divorce lawyer. For a while, parts of this plate stayed above water as the last gasp of the Antarctic land bridge. It was Earth's version of that one thread still connecting your hoodie after the zipper breaks. These final connections might have persisted as chains of islands, but just like that fraying hoodie, the connection couldn't last forever. Eventually, this small but mighty plate became the final nail in the coffin of the land bridge connecting the two continents. Just like all the tectonic plates, this one was also on the move. As it expanded eastward, it opened a new passage of water called the Drake Passage, slowly covering the Antarctic land bridge with ocean water. The process was like pulling open elevator doors. At first, just a crack, then wider and wider until the connection was completely broken. This geographical divorce had chilling consequences. The new Drake Passage allowed the Antarctic circumpolar current to form, creating an endless loop of cold water that isolated Antarctica, shaped its land, and even cooled the entire planet. This current acts like a wall around Antarctica, blocking warm water and invasive species while regulating global climate. Eventually, Antarctica turned into an icebox that is 98% covered in ice sheets, and that holds about 61% of Earth's fresh water. Nowadays, this continent holds the title of the windiest, driest, and iciest place on Earth. It's a frozen desert where temperatures plunge below -128.6 degrees Fahrenheit, cold enough to freeze your breath mid-air. A layer of ice there can be more than a mile thick, and it expands even further in winter to cover an area larger than the continental United States. Today, if you want to travel to Antarctica, the quickest sea route is through the Drake Passage, a 500-mile-wide body of water that is narrow enough for the winds to scream across thousands of miles, transforming into monstrous waves that can tower up to 49 feet, though calm days create waves only 13 to 16 feet high. Still twice as tall as Atlantic waves, mind you. This is probably why sailors call this stretch of ocean the Drake Shake. But tectonic movement isn't just about shifting continents. It's Earth's ultimate life support system. You see, about half of our planet's heat comes from radioactive decay in the core. Thanks, uranium-235. Something like nature's nuclear reactor. This heat is behind everything from volcanoes to the very plate motion that once connected Antarctica to South America. And it only comes out of the core because of tectonic movement. Without this internal heat engine, Earth would be just like Mars. When the plates move and release heat, they also release CO2 gases into the atmosphere, regulating the temperature of our planet. And when the plates move underwater, they take a lot of this CO2 back to Earth's interior, recycling all this gas. This is why the plates can change our air, climate, and even the evolution of life itself just by moving around. But billions of years ago, these plates were not moving around. Back then, it was like Earth was wearing a solid ceramic shell with many cracks. But even without tectonic movement, the heat managed to escape through these cracks in a process called stagnant lid tectonics, kickstarting all life on Earth. And no, tectonic movement is not a thing of the past. Earthquakes are the living proof that it is not just happening today, but might repeat again on a more dramatic scale in the future. You see, to form supercontinents like Pangaea, smaller megacontinents have to dive beneath another. And scientists predict that a similar process might create a new supercontinent called Pangaea Proxima in 250 million years. By then, humans might be extinct or living on Mars, but Earth's tectonic dance will continue, even without us. Not bad for something that moves more slowly than a traffic jam. Turns out, Antarctica and South America used to be BFFs before all that tectonic drama split them up, like a messy breakup that literally froze one of them out. Now, they just awkwardly mirror each other from across the Drake Passage. Classic exes. Scientists discovered something Atlantis-like near Australia. There used to be an entire continent that's now underwater. Here's what happened to it. Around 70,000 years ago, during the last ice age, there was a huge landmass called Sahul. It was located in the southwestern Pacific Ocean. This ancient supercontinent connected what we now know as Australia, New Guinea, Tasmania, and the Aru Islands into one giant piece of land. Imagine lush tropical rainforests surrounded by beautiful mountains. Sahul's tallest mountains were in the New Guinea highlands, with peaks reaching over 13,000 feet. This beautiful place was home to a variety of unique animals, most of which were pouched creatures. But back then, they weren't just koalas and kangaroos. Sahul was filled with different types of grazers, burrowers, scavengers, and predators. It was home to a huge diprotodon, a powerful hunter Thiosolio, and a horrifying Megalania, a creature that's much larger than any living lizard today. It was a unique place because the rest of the world was filled with placental animals at the time, like wolves, elephants, and humans. In Sahul, the only normal mammals were bats and rodents. But not all its parts were the same. The Timor, Arafura, and Carpentaria regions were covered by hot savanna and dry forests. It looked kinda like modern Australia, hot air deserts with scrubland, steppe, and temperate forests along the eastern coast. Back then, people were migrating all across the world. They made an incredible journey from Southeast Asia to Sahul and first arrived here from 60 to 45,000 years ago. They mostly traveled by foot and crossed the sea using bamboo rafts and simple boats. They came there from an ancient landmass called Sunda, which includes parts of Southeast Asia. They traveled across a series of islands known as Wallachia and eventually spread across Sahul. And it wasn't a small journey. Sahul was huge, around 4.1 million square miles. That's bigger than the USA or Canada. It stretched from the equator to around the southern part of New Zealand. So they arrived in what is now Australia and became Australia's first people. Scientists think that Sahul had a population of 500,000. We've discovered cave paintings that date back around 40,000 years. It's a hunting scene depicting an anoa, or miniature buffalo, facing figures of humans and animals. Researchers are trying to figure out how these early settlers moved across Sahul and where we might find archaeological evidence of their journey. To do this, they created a landscape evolution model. The simulation showed how Sahul changed between 75,000 and 35,000 years ago. It showed potential migration routes and archaeological sites. Humans likely traveled along coastlines and rivers. But how did Sahul get submerged off the coast of Australia, similar to the mythical Atlantis? During the last ice age, much of the Earth's water was locked up in large ice sheets and glaciers. The sea levels were much lower than they are today. After that, the global temperatures increased. The ice sheets melted and the sea levels rose, flooding the land bridges that once connected different parts of Sahul together. About 8,000 years ago, New Guinea separated from mainland Australia, and then, about 6,000 years ago, Tasmania did the same. We still can explore the underwater parts of Sahul thanks to new technology. Divers explore and collect samples directly from the ocean floor. Underwater drones can go to places that are too deep or dangerous for humans to explore. And with sonar mapping, scientists use sound waves to create maps of the ocean floor. It's like using an echo to see what's underwater. The sound waves bounce off the seabed and come back, helping us create a picture of what it looks like. Deep underwater, archaeologists have found stone tools and other artifacts. They also discovered fossils of animals like Diprotodon and Thylasolio. By studying the underwater terrain of Sahul, they learned about the ancient rivers, lakes, and coastlines that existed during the Ice Age. But Sahul isn't the only underwater continent. Sahul isn't the only hidden gem of Southeast Asia. Take Sundaland, a place made up of Sumatra, Java, Borneo, and some other islands. This place was crazy huge during the Ice Age, but now almost fully underwater. Almost, but not entirely. The parts above the ocean are teeming with life. If you like birds, check this place out. It has almost a fifth of the world's bird species. You can spot colorful birds like the Java hawk eagle and the Bali starling among the lush forests. It's also a home to a fourth of Earth's fish species. Sundaland's waters are a haven for marine life, even the most exotic animals like the Asian arowanas. It's also a treasure trove of flowers. That's where you can find Rafflesia and Titan arum, the world's largest flowers. This makes it very similar to Zealandia. Zealandia is a long, narrow piece of land about half the size of Australia. It broke from Antarctica about 100 million years ago. Just like Sundaland, it isn't fully underwater. 7% of it stayed above sea level. This sticking out little piece is what we now call New Zealand, along with Stewart Island and some smaller islands. These pieces of Zealandia are lush and warm. They're packed with volcanoes, mountain ranges, beautiful natural geysers, and hot springs. Local people, Maori, use these hot springs for cooking. People place corn, eggs, and vegetables in baskets and lower them directly in the hot springs. Sometimes they cook food in a pit oven using heated rocks. Another hidden world is known as Argoland. This mysterious landmass was once part of Australia, back when dinosaurs chilled around. It drove scientists crazy for decades. They knew it existed because it left a huge stretch on the ancient seafloor, the Argo Abyssal Plain. About 155 million years ago, it broke off from Australia, saying bye-bye. The continent drifted somewhere north, and when it reached Southeast Asia, it just vanished. Scientists had no idea where it went, but recently they finally found its remains. Turns out, poor Argoland's lower parts started drowning into the Sunda Trench, a horrifyingly deep oceanic pit. The Earth's crust sunk into the mantle. Meanwhile, the upper parts of Argoland were pushed upward, grabbing the younger rocks on land. Because of this, Argoland broke apart into a bunch of smaller pieces. These pieces formed parts of Borneo, Java, Sulawesi, and other regions. The remains are buried under Indonesia and Myanmar. Imagine a colossal landmass the size of Greenland, Greater Adria. Its journey began about 240 million years ago when it broke away from the supercontinent Gondwana. It started moving north, and after 100 million years of enjoying the warm seas, it suddenly crashed into Europe and shattered into pieces. Most of these pieces went deep into the Earth's mantle, but some were scraped off and became part of mountain ranges like the Alps. Today, the remnants of Greater Adria are scattered across more than 30 countries, from Spain to Iran. That's why they're hard to look for. Seychelles was also once part of Gondwana. Yep, these idyllic islands are sitting atop of the ancient continent. We know a lot about it because of its fascinating granite outcrops. 100 years ago, Alfred Wegener discovered continental drift, but no one believed him. These granite outcrops helped him prove that he's not crazy and that tectonic plates really are moving. The Seychelles broke off from India and Madagascar and eventually became a sad loner in the Indian Ocean. This probably happened because of some insanely active volcanoes in the Deccan Traps. But now, the islands are home to unique species both on land and in the coral reefs nearby. Mauritius broke off from India after the dinosaur wiping. Along its journey, it stretched into a long ribbon-like shape and also broke into pieces. Now it's all scattered beneath the Indian Ocean. Scientists stumbled upon this lost land by studying tiny ancient crystals called zircons. These zircons are like time capsules. They date back an astonishing 660 million to 2 billion years. That's even older than Mauritius itself. These ancient crystals hinted that there's another Atlantis somewhere nearby. Turns out there are hidden continents all around the world, and maybe we'll discover more of them in the future. One interesting thing that happens in map design is the so-called Baltimore phenomenon, or Baltimore effect. This phenomenon happens when a city or another object is left off a map because there's just not enough space, while smaller cities make the cut simply because there's room for them. The name comes from Baltimore, Maryland, which often gets left out of maps because it's surrounded by bigger cities like Washington, D.C. But on the flip side, sometimes smaller and less well-known cities like Alice Springs in Australia end up on the same map simply because there's enough space for them. Like at this scale, Alice Springs, which give or take 25,000 inhabitants, is labeled, but the huge city of Guangzhou, with over 14 million people, is somehow not. This phenomenon is more common on automated mapping sites, but it doesn't happen at every zoom level. On popular sites like Google Maps and other similar ones, you'll only start seeing Baltimore show up at certain zoom levels, like the 5th, 6th, or 7th zoom. Cartographers can tweak their maps to make sure they're useful and convey spatial information effectively, finding the right balance between showing important details and keeping the map clear and focused. The best maps are the ones that show key elements clearly, while still accurately representing the world. But Alice Springs is not the only weird thing on the map of Australia. Look at the time zone map. This 10.5 section looks a bit off, huh? Well, Australia is officially divided into 3 standard time zones: Western, Central, and Eastern. Australian Central Time aligns with UTC plus 9:30, with individual states and territories deciding whether to observe daylight savings time. Australian island territories and Antarctic stations contribute to the complexity of the time zones. Despite this, Australian time zones are generally easy to understand. In addition to the official time zones, there is an unofficial hybrid time zone called Australian Central Western Standard Time. This time zone is halfway between Western Time, UTC plus 8, and Central Time, UTC plus 9:30, making it UTC plus 8:45, a unique quarter-hour difference. Australian Central Western Standard Time is only observed in a small area in far southeastern Western Australia, along the Eyre Highway. The Australian Central Western Standard Time area includes settlements such as Cocklebitti, Madura, Mundrabilla, Eucla, and Border Village. Only a few hundred people live in this region, making it easier for them to agree on a non-standard time zone. Despite the lack of official approval, Australian Central Western Standard Time continues to be followed due to the significant time gap between Western and Central time zones, especially during the summer when South Australia observes daylight saving time and Western Australia does not. The use of this unique time zone can often lead to confusion, even amongst the locals. Eucla Police, for example, operate on Perth's time zone, causing occasional tardiness to events such as community gatherings. Locals mentioned that in the past, Eucla operated on its own unofficial time, which made things simpler, before the transition to align with Perth time. They also face confusion as their location in South Australia does not observe daylight savings. The history of the Australian Central Western Standard Time dates back to the establishment of a telegraph station in Eucla in 1877. Although the exact origins of this time zone are unclear, it is speculated that it was adopted to avoid confusion at the telegraph station located on the border between Western Australia and South Australia. UTC plus 9:45 was historically utilized in Australia as a time zone known as Central Western Daylight Time. Certain roadhouses along the Eyre Highway in South Australia and Western Australia adopted UTC plus 9:45 during the summer months when South Australia observed daylight savings time. While not officially recognized by the authorities, the boundaries of this time zone are clearly outlined and often depicted on local road maps. 5 locations in Australia, including Border Village, Kaiguna, Eucla, Madura, and Mundrabilla, previously observed UTC plus 9:45. Currently, these areas operate on UTC plus 8:45 due to Western Australia's lack of daylight savings time. Australia is not the only example of weird time zones. China has a population of approximately 1.5 billion people. and it's the third largest country in the world. Despite its vast size, China operates on a single time zone known as Beijing Time or China Standard Time. This unique time zone covers almost 5 geographical time zones within the country. At times, in some cities in China, the sun rises as late as 10 a.m. People often have lunch after 2 p.m. or even after 4 p.m. if they're not in a hurry. Since 1991, daylight savings time has not been observed in China. However, the region of Xinjiang, located in the western part of the country, follows Xinjiang time, which is 2 hours behind China Standard Time and is considered an unofficial time zone. Nepal also has its unique time zone, as it operates on Nepal time all year round without the use of daylight savings time. It's a bit unique compared to other countries because it has a UTC offset of plus 545, meaning that Nepali clocks are 5 hours and 45 minutes ahead of Coordinated Universal Time. This is only a 15-minute difference from neighboring India, where the standard time used to be the same until Nepal decided to set its own time zone in 1956. Now, let's examine the map of Europe. Great Britain, Portugal, and Spain are all located at roughly the same latitude. However, despite this, it's 1 hour earlier in Portugal and the UK compared to Spain. Why is this the case? In the 1940s, Spain was instructed to switch to German time, a directive that was accepted by Spanish authorities. Over time, despite changes in leadership, Spain remained in the same time zone, resulting in it being 1 hour behind its neighboring countries at the same latitude. But like many other countries, Spain sticks to daylight savings time. Greenland would rank as the world's 12th largest country if it were independent, but it's currently part of Denmark. The country has 3 different time zones. Most of it is 3 hours behind Greenwich Mean Time, except for only one town on the eastern coast, which is 2 hours ahead. Thule Air Base in the northwest operates on GMT-4, while the tiny population of Danmarkshavn sticks to GMT. Daylight savings time was implemented to give us more daylight during the evenings after work, which could help save energy by lowering the need for lights and heat. It was first suggested by Benjamin Franklin in 1784 to align waking hours with daylight and conserve energy, and was implemented in Port Arthur, Ontario in 1906. Since then, many countries have adopted the practice, though some regions near the equator or at high latitudes opt out due to minimal variations in daylight hours. In the United States, daylight savings time is observed almost everywhere, except in Hawaii and Arizona. Arizona's scorching hot weather makes daylight saving time kind of pointless. People there would rather get stuff done in the cool morning hours than sweat it out in the evenings. However, the Navajo Nation, which is autonomous Native American territory, sticks to the same daylight savings time schedule as the rest of the country. Even though it spans 3 states, Arizona, New Mexico, and Utah, they keep the time consistent across their lands. As for Hawaii, due to its tropical location, the amount of sunlight doesn't change much throughout the year. If Hawaii changed its time zone to UTC-9 during daylight savings time, the sun would rise at around 7 a.m. in June. This is because most of the islands are situated towards the west of the Hawaii-Aleutian time zone, and theoretically should be in the next time zone to the west. In the past, Hawaiian Standard Time was based on a different longitude than it is now.
Some mistakes have the power to change the course of history. One such story has to do with an old, boring key that could have saved the Titanic from its infamous demise. The key belonged to the crow's nest locker that housed binoculars, which could have helped the lookout spot the iceberg sooner. There's more. The key wasn't even on board the ship when it set sail. The second officer took it with him when he was taken off the ship at the last minute. As the story goes, the officer forgot to hand the key over to his replacement in his hurry to disembark. So, when the lookouts were in desperate need of binoculars, they were out of luck. One of the lookouts, named Fred Fleet, even testified that if they had had binoculars, they would have spotted the iceberg in time to avoid it. And when asked how much sooner, Fleet replied, "Enough to get out of the way." In 2015, some auctioneers got their hands on Blair's key and presented it as one of the most important artifacts from the Titanic. They truly believed it could have saved the ship. Blair kept the key as a souvenir and passed it down to his daughter, Nancy. At one point, it was up for auction with a price tag of over $80,000. Blair himself was quite the hero, it seems. A year after the Titanic disaster, he was awarded a gallantry medal for saving a crewman who had fallen overboard while he had been on board the liner Majestic. He may have forgotten a key, but he sure didn't forget to be a hero when it counted. This next story is both funny and tragic. It's about NASA's lost $125 million Mars Climate Orbiter. The spacecraft engineers failed to convert from English to metric measurements before the craft was launched, and as a result, they lost it. The navigation team at the Jet Propulsion Laboratory used the metric system of millimeters and meters, while Lockheed Martin Astronautics in Denver used the English system of inches, feet, and pounds. JPL engineers mistook acceleration readings measured in English units of pound-seconds for a metric measure of force called Newton-seconds. What's worse is that none of JPL's quality control procedures caught the error in the 9 months it took the spacecraft to make its 461 million-mile flight to Mars. That's a long time to be lost in translation, don't you think? The miscalculations were enough to throw the spacecraft so far off track that it flew too deeply into the Martian atmosphere and was destroyed when it entered its initial orbit around Mars. It's embarrassing to lose a spacecraft to such a simple math error. And it's hard to think of another example of such a large loss due to English versus metric confusion. Ever heard about the mathematical mistake that led to the discovery of the New World? Spoiler alert, it involves a guy named Christopher Columbus and a really big globe. Back in 1492, Columbus set sail from Spain with a mission to find a new trade route to Asia. He was convinced that he was less than 3,000 miles away from Japan, and just a bit more sailing would get him to the Indies with all their tasty spices. The only problem was that Columbus was a bit off in his calculations, like way off. He made a mistake in estimating the size of the globe, which led him to believe that Earth was far smaller than it actually is. Now I know what you're thinking. Wasn't Columbus afraid that he would fall off the edge of the world? Contrary to popular myth, Columbus and his crew knew the Earth was a globe, just like the ancient Greeks did 2 millennia earlier. They weren't worried about falling off the edge, but rather about the size of the ocean they planned on crossing. And to make matters worse, Columbus had no idea that an unknown landmass existed between Spain and Asia. After weeks at sea, Columbus finally reached the Caribbean. He believed that he had landed on the outskirts of Asia, and so named the islands the West Indies. He went on to explore the Caribbean and the northern coast of South America. But here's where things get really interesting. Even though Columbus insisted until his last day that he had reached Asia, another Italian explorer named Amerigo Vespucci mapped the eastern shore of South America down to Brazil and proved conclusively that Columbus had actually discovered a whole new world. A German mapmaker saw Amerigo's maps and labeled the new landmass America after him. And since his maps were super popular at the time, the name stuck. One man named Alexander Fleming stumbled upon one of the most significant medical discoveries of all time by accident. At one point in his career, Fleming observed the demise of many people from uncontrollable infections. Antiseptics were used to fight this, but they often did more harm than good. In 1922, while he had a cold himself, Fleming transferred some of his, nasal discharge to a petri dish and left it on his cluttered desk. When he finally examined it weeks later, he found that an enzyme had some antimicrobial properties. It wasn't until 1928, when Fleming left an uncovered petri dish next to an open window, that he stumbled upon the discovery that would change the world. The dish became contaminated with fungus spores. And when he examined them under the microscope, Fleming discovered that the bacteria near the fungus were dying. He managed to isolate the fungus and found that it was effective against numerous things that cause diseases. And thus, penicillin was discovered. As Fleming himself put it, "I did not discover penicillin. Nature did that. I only discovered it by accident." Talk about a lucky break. In the early 1520s, the east coast of the United States of America was a big mystery waiting to be solved. The Spanish found Florida, and the English and Portuguese found Newfoundland, but the area in between was like a blank spot on the map. France decided to take action and sent an expedition to explore the area. They chose a guy called Giovanni da Verrazzano to lead the trip. For this expedition, he got 4 ships. Unfortunately, 2 of them were shipwrecked, and a third one went home after doing some other business on the Spanish coast. Only the flagship, La Dauphine, crossed the Atlantic with Verrazzano and his 50-man crew. Verrazzano set sail from Madeira and landed at Cape Fear. From there, he sailed south, but got a little scared of running into the Spanish, so he returned somewhere north of Charleston. He anchored not far from his original landing spot, but unlike other explorers, he preferred to anchor well out at sea. He did send a boat to the shore, and he met the natives. They were described as wearing just some animal skins covering their bodies and garlands of bird feathers. As Verrazzano sailed along the coast, he reached the outer banks of North Carolina. He thought that the waters he discovered were those of the Pacific. In reality, what he'd stumbled upon was the Pamlico Sound. He thought that North America was just a long, extremely narrow strip of land. This mistake led mapmakers to show North America as almost completely divided in two. Moving on, Verrazzano reached a beautiful place that he called Arcadia, probably Kitty Hawk, North Carolina. Sailing further north, he missed the entrances to Chesapeake and Delaware Bays because he kept quite far from the coast until New Jersey. Then, the moment we've all been waiting for, Verrazzano discovered New York Harbor, and he anchored in the Narrows. Later, it was named after him, and now it is spanned by the Verrazzano Narrows Bridge. Once Verrazzano's sea appeared on the map, it became widely accepted and impacted loads of future explorers. For example, Henry Hudson went looking for a passage to the Pacific in the middle latitudes of the continent. But, as it turns out, the Englishman never did find the Pacific Ocean anywhere near Virginia. And the cartographic myth eventually faded away. It's funny to think about how a mistaken belief could have such an impact on history.
Imagine you decided to take a road trip the old-fashioned way. And by that I mean you decide to do it without the help of any technology. What? So you go to the nearest convenience store and buy a map of each state you plan to pass through. You buckle them up on the passenger seat right next to you and set off on your adventure. During your first week, you arrive in the state of New York. You wave bye-bye to Lady Liberty, eat a slice of pizza, and head upstate. Near the Catskills, you notice you're running low on gas and decide to stop in the nearest town to fill up your tank. You check your map, and it appears that the nearest place is a small village called Agloe, right at the next intersection. You drive a few minutes and pass through a sign that says, "Welcome to Aglo, home of the Aglo General Store." Well, this must be it, you think to yourself. But the town is strangely empty. You can't find the store or the gas station you were looking for. There are no houses. You start to think there might be a mistake. Aglo doesn't seem to exist. This story may sound made up, but it could have actually happened to anyone passing through New York a few years ago. Actually, the so-called town of Aglo is what is called a phantom settlement or a paper town. There are several of these around the world, but Aglo is probably the most famous. Paper towns are basically fake towns. That is, they don't really exist. They're made up of Easter eggs put there by map makers as a kind of copyright trap. Maps are tough to make. To create a map from scratch, one has to do years of fieldwork or analysis of satellite photos. That's why plagiarism has always been rampant among map makers. It's pretty easy to redraw the same geographical features from one map onto a new map, and it is hard to get caught. People are, after all, drawing the exact same world. That's why map makers came up with a way to catch individuals stealing their data. Some map makers may include a mountain that is bigger than they are in reality. Others might add a slight turn on a road, where in reality there is none. For example, in the early 1970s, a fake mountain peak appeared on some Boulder County maps. The addition of this previously unknown peak, called Mount Richard, into local maps began to confuse Colorado rock climbers at the time. It turned out that Mount Richard was one of these copyright traps, put there by a local maps man called Richard Ciacci. Let's just say he must have decided to pay a tribute to himself with this little addition. Now, adding a paper town is perhaps one of the most extreme solutions, one that map makers hope goes unnoticed. But that's not what usually happens, which leads us back to the Aglo story. Map makers Ernest Alpertz and Otto Lindbergh from the CDG, General Drafting Corporation, were part of the largest map publishers of the 1930s. Back then, the company was commissioned to create a map of the state of New York. That's when the two men had an idea. In order to prevent copyright infringement, they would create a phantom settlement combining parts of their names together. They came up with the strange name Aglo and added the fake town along Route 206 near the water reservoir of Catskills in upstate New York. The area was supposed to be, in reality, a dirt road. Years later, Rand McNally, another map designing company, produced a map of New York that included a town called Aglo in the same location where CDG had originally placed it. Lindbergh was convinced that he had a copyright case against his competitor, but the story just kept getting more complicated. Both companies went to settle the case in court, but as it turned out, McNally had a legitimate reason for adding Aglo to their version of a New York map. You see, in order to fabricate their maps, McNally did a thorough research on real estate and establishments located in each existing town. And as it turned out, Aglo was not an empty town when they drew their map. Records show that the town housed an establishment named Aglo General Store. Sure, it was the only building in town, but that was enough for the map makers to believe that such a town really existed. They added Aglo to the map like they would add any other town with physical establishments. It seemed they weren't infringing any copyright if this once phantom settlement had somehow come to life. The plot twist is that CDG's Alpers and Lindbergh could never have foreseen that someone would decide to occupy a made-up town. But it happened. One day, someone bought a map from a regional gas station that had Aglo marked on it. The person wanted to open a store more or less where Aglo existed, so they decided to name the store after the town it was in. They trusted the accuracy of the map they bought and named their business Aglo General Store. After all, why would there be a non-existent town on an official map? The general store didn't last many years, only enough to turn this story into a mess. On the bright side, this whole debacle turned Aglo into a super famous fictitious settlement. It became a tourist spot, with people driving from all over the U.S. to get a picture of the town's welcome sign. Now, as we said before, paper towns are plenty around the world and over time, too. A 2005 BBC documentary revealed that the city of London alone had over 100 tiny fake streets or paper streets around the city. For instance, the so-called Moat Lane is supposedly a curving road in Finchley, North London. But if you ever decide to go visit, you'll find nothing but trees and gardens. And what about Argleton, a town in the north of England? Or, more accurately, an empty field in northeastern England. Argleton existed for a while on Google Maps. There were hotel listings and apartments for rent in town. Well, the only thing is that they weren't really in Argleton, but rather in nearby settlements. It's believed that Google Maps imported these fake streets into its database as they used renowned copyrighted atlases as their sources. But as the truth about these paper streets surfaced, the company later deleted them. If we turn back the clock a few hundred years, we'll find another mystery story involving a possible phantom settlement. But this isn't a tiny town at an intersection, but rather an entire island. Bermejo Island was speculated to be a tiny inhabited island. It appeared on many maps of the 16th and 17th centuries and was a hot spot for Spanish explorers. Its location sometimes varied slightly from map to map, and occasionally its name appeared as Bermeja, but its existence seems certain enough. It wasn't until the 18th century that the island stopped being depicted in maps altogether. This island's last appearance dates back to a 1921 edition of a Mexican atlas, and then, poof, it dropped out of the horizon altogether. The case of Mexico's disappeared island has raised many questions. Did it sink? Was it destroyed? Are people simply looking for it in the wrong place? 3 official investigations took place in 2009 to locate the island. They used high-end technologies, scouring Mexico's oceans and seabeds. Yet, Bermeja remained nowhere to be found. One can't help but wonder if the island ever existed at all. Similar to modern-day map makers, 16th and 17th century map makers had their way to trick map users. Instead of copyright traps, these fake towns or even fake islands served as a way to fool and confuse enemies and unwanted voyagers. Since a long time has gone by, it's hard to know whether Bermeja was just another phantom settlement. It stopped being depicted on maps, but this mysterious case still leaves people baffled and confused.
You lie down facing the scorching sun in the middle of the desert when suddenly you smell something extremely foul. You try to crawl to the source to see if maybe someone there can help you, but all you see is a large hole in the middle of nowhere. You crawl there and stick your head down the hole. You hear something really faint down there, but it's too dark to see anything. Still, the foul smell tickles your nostrils. You turn away in disgust and stand up to get a better view of it. The hole is roughly 100 feet in diameter, with nothing around it. You've been wandering around the desert for days and just ran out of food and water, but far away, you see what looks like a small hut. You walk there for another couple of hours until you reach the outskirts of a village. A local man riding a camel tells you that you're in the Al-Mara province in Yemen's eastern region, which is quite close to Oman. He immediately takes you to his mud hut, feeds you, and gives you some water. Feeling refreshed and full, you ask the local about the hole in the desert floor. His eyes sink in and his face grows pale. He grabs you by your sleeve in silence, throws you out of his hut, and slams the door shut. You try to knock on his door once more, but he ignores you. Out ahead is the village market, where you could surely get some answers from people. You head over there, and everyone starts staring at you as if you're some kind of threat. They sense something's off about you. You put on your hood and make your way to a merchant. While you purchase some food, you ask the seller about the hole, but he refuses to sell you anything. He even pushes you off to the pathway. You make your way to another vendor and ask about the hole. At first, he's reluctant to tell you anything, but after you buy a few items from his shop, he finally concedes. He takes you to a small inn and seats you down. He tells you to keep your voice low when talking about it. He then orders a beverage for you and begins explaining everything he knows about the hole. Legends have it that the well of Barhut, which is in Hadramaut, is a cursed place. a prison for spirits. He claims that any object that goes near it eventually disappears. The server comes back with 2 refreshing drinks, and the man quickly stops talking. As soon as the server leaves, he resumes telling you about the well. The reason why people were avoiding you when you mentioned the well was because it's believed that it brought bad luck to anyone who was near it. They were even able to feel it through you. The man tells you that he doesn't believe in such superstitions, but you want to find out more. At night, you head back to the well to find out if what he said was true. You sit down next to it and concentrate all your senses. It's quiet, nothing but the desert wind brushing against the sand. You hear something that sounds like a whisper coming from the hole, as if calling you to go inside. You get up from your meditation and walk towards the hole. The sound gets louder, but you still can't make anything of it. You stick your head down the hole to listen while holding your breath, but it just sounds like gibberish. The next day, you get some rope and pikes and wait till nightfall to prepare for the next step, descending down the hole. Nighttime comes again, and you set up the ropes and tie them around a tree. You climb down while holding the rope with one hand and a torch with the other, and scale down. You try to breathe through your mouth, but you start to feel like you need to catch deeper breaths the lower you go. The hole is believed to be around 850 feet deep, but you were only able to go down around 20. You didn't expect it to be that deep. You start climbing back up, but you decide to drop the torch into the hole to see how far it goes. You see the flame getting smaller and smaller as it disappears into the darkness. Maybe the man was right, just village folklore about something they can't explain. Scientists claim that the hole is millions of years old and has practically no ventilation. Even though it's been around for such a long time, it remains as mysterious today as it's always been. You're walking in Siberia, looking out for some reindeer, when suddenly you hear a loud explosion from the distance. All of your reindeer scatter around, and you're too much in a frenzy to collect them. You run to the source of the blast and find a huge crater in an area you just passed through. In August 2020, a massive hole was discovered in Siberia, Russia, being around 100 feet deep and around 65 feet wide. The local residents and researchers were stunned to find it there. This is the 9th hole documented in the region since 2013. You call the local authorities, and a huge team of scientists arrive with weird-looking scientific equipment. They claim this crater is the biggest one they've seen so far. Most of these craters were found by accident when people went on non-scientific outings by helicopter or by hunters and herders. Scientists aren't able to wrap their heads around it, but they knew exactly where to start. Permafrost, the thing that covers 2/3 of the whole country's territory. Scientists believe that by studying the permafrost, which contains certain chemicals, we can find out why these craters are popping out. Samples of the craters contain a lot of chemicals, but most notably, methane. Scientists took plenty of samples of the frozen soil from the ground and the ice. They had to descend down the crater to collect most of them. And within 2 years, these craters end up turning into lakes. According to their studies, the gases, which are mainly made up of methane, accumulate in the upper layers of the permafrost, and they can come both from the deep layers of the earth and those close to the surface. These gases end up getting trapped in the frost as they accumulate, creating enough pressure to burst through the frozen ground. They claim that these giant holes are a result of the growing temperatures. But that's just one theory. They're still not really sure how they could have formed. But because most of these craters form in remote areas of the Arctic and take years to shape, no one really talks about them. You're fast asleep in the city of Fukuoka, Japan. At around 5 a.m., you hear a loud explosion and feel the ground shake. Japan is prone to earthquakes and tsunamis, so you're prepared for the worst. But the ground isn't rumbling and the building isn't shaking anymore. You check the power, and nothing. The whole apartment and neighborhood is completely dark. You look far out from the balcony and see a huge hole in the middle of a 5-lane road. You leave the building and join the crowd gathering outside. The hole is about 65 feet deep, and it swallowed everything around it. The traffic lights, sidewalks, and a bus stop are all gone. Even parts of buildings are destroyed. leaving the support beams still standing. The whole subway system is totally dysfunctional, and about 800 households are experiencing blackouts. Even the airport and subway had a bit of it. The local authorities evacuate the entire area in case more sinkholes or gas explosions occur. A few days later, it's all fixed. It only took the Japanese engineers and contractors 48 hours to fill it up, and a week to reopen the road to the public. The explosion might have been caused by some construction on a subway line, but the sinkhole is sinking again. People noticed that the road seemed to decline by about 3 inches in heavy traffic. But with quick maintenance, Japan can fix anything in the fastest way possible.
A long time ago, a huge meteorite smashed into the Earth with a horrible destructive power. It was several times bigger than the one that wiped out the dinosaurs 65 million years ago. Luckily, there were no lives it could have taken, or else it would have been a real catastrophe. Now, scientists think it did leave behind a huge footprint, the massive Antarctica impact crater that is bigger than the entire state of New York. The location also has a gravitational Wilkes Land anomaly going on. At first, scientists noticed something weird here when they measured Earth's gravity in that region. A strange gravity hole, or a negative gravity anomaly. Later, with better technology, they found something even weirder. There was a positive gravity anomaly inside that gravity hole, a spot with stronger gravity. This kind of structure, called a mascon, short for mass concentration, often shows up in places where giant space rocks or meteorites have slammed into the planet. When a meteor hits hard enough, it punches through the Earth's crust and shakes the mantle below. It can spring back up and leave behind a super dense plug of material, which causes stronger gravity right in the center of the crater. It's something like a frosty donut, with ice filling the gap and a dense center rising up from underneath. In 2018, scientists used advanced scanning techniques to study and map the Wilkes Land meteorite impact in more detail than ever before. They saw that it wasn't a perfect circle, but more of a U-shape, and the northern part looked like something had broken it apart. It possibly happened when Australia split away from Antarctica about 35 million years ago. Some scientists even think you can still see parts of the crater in southern Australia today. This clue also supports the idea that the giant crater under Antarctica formed before the continents broke apart. There have been different ideas about what created this strange formation. Some said it might be a volcano or an eroded valley, or even a sedimentary basin. That is a place where sediments build up over millions of years. But many scientists now believe the most likely explanation is a massive meteor impact. It was possibly one of the biggest to ever hit Earth. A 2015 study even estimated the age of the crater as its size matches the kind of space rocks that smashed into Earth between 4.1 and 3.8 billion years ago. The Wilkes Land meteorite impact was so powerful because the meteor that caused it could have been up to 30 miles wide. That's 4 to 5 times wider than the Chicxulub meteor that wiped out the dinosaurs 66 million years ago. Even that meteor was enough to cause massive destruction with wildfires, acid rain, tsunamis, and a climate crash that wiped out about 75% of all existing life. So it was lucky in a way that the meteorite that gave us the giant crater under Antarctica visited at a time when there were only microbes and no plants or animals on Earth. It didn't cause mass extinction or leave behind charcoal from ancient fires, but it may have changed the entire planet. Still, scientists haven't put the Wilkes Land anomaly mystery in the solved files because the crater is buried deep under Antarctica's thick ice sheet. It's hard to study up close. Scientists say we can't rule out the other ideas just yet, but if the meteor theory is right, then the Wilkes Land crater could be the largest known impact crater on Earth. So far, this title belongs to another contestant, the Vredefort crater in South Africa. Right now, the crater is around 99 miles wide, which is huge. But it's not as wide as the Chicxulub crater in Mexico, which is about 112 miles wide. but the Vredefort crater used to be way bigger, around 155 to 174 miles wide, before time and erosion wore it down. That means even though the Chicxulub impact was striking, the Vredefort impact was likely even more powerful, the biggest one we know of that hit Earth. According to the latest study, that asteroid was 12.4 to 15.5 miles wide and might have hit Earth at a speed of 45,000 to 56,000 miles per hour. It's important for science because knowing the real size of this impact helps us build better models to understand Earth's geology and how giant impacts shape planets, even beyond Earth. Measuring ancient craters is really tricky. Over 2 billion years, erosion wears away the edges and newer rocks form over the crater. That's what happened to Vredefort. Now, only small bits of the original crater rim are visible, and the rest is hidden under newer rock. To figure out its true size, scientists studied minerals like quartz and zircon found around the crater. These minerals still have fractures and shock patterns that show us how powerful the blast was. Wilkes Land Anomaly isn't the only case on our planet where gravity is acting weirdly. For over 40 years, scientists were trying to solve a strange mystery in Canada. Parts of the country, especially around Hudson Bay, seem to have less gravity than the rest of the world. That means if you stepped on a scale there, you'd weigh just a tiny bit less than usual. Researchers first discovered this weird difference in the 1960s when they were mapping Earth's gravity. Gravity is linked to mass. The more mass there is, the stronger the gravity. And since Earth isn't shaped perfectly like a ball but is slightly squashed at the poles and bulges at the equator, it makes sense that its mass isn't spread out evenly. So, the first out of the two main theories to explain the Hudson Bay mystery has to do with magma. Yes, that super hot, gooey rock deep under our planet's surface. Magma constantly churns like boiling soup in a process called convection. As this magma moves, it can drag parts of Earth's crust down with it. That makes the area lighter, which lowers the gravity. The second area has to do with the Laurentide ice sheet, a massive glacier that covered much of Canada during the last ice age. This ice was up to 2.3 miles thick in some parts of Hudson's Bay. That's like stacking 10 Empire State Buildings on top of each other. Because it was so heavy, the ice pressed the land down like a thumb on a sponge. Even though the ice melted away about 10,000 years ago, the land underneath is still slowly bouncing back, kind of like a memory foam mattress after you get up. This slow rise is called glacial rebound, and it's happening at less than half an inch per year. Until the land fully bounces back, which could take 5,000 more years, it will continue to have less mass, and that means less gravity. Both of these theories are right. To figure this out, scientists used super advanced satellites, which floated around 300 miles above Earth for several years. These satellites flew in pairs and detected how far apart they were pulled as they passed over areas like Hudson Bay to measure tiny changes in gravity. When the front satellite passed over a low-gravity area, it drifted just slightly, and that change was recorded. Thanks to this research, scientists created detailed maps showing what Hudson Bay looked like during the last ice age. They discovered two huge bulges on the west and east sides, where the ice was thickest. And those spots have the weakest gravity today. The effects of this are still visible, and while sea levels are rising in most parts of the world, the land around Hudson Bay is rising so fast that sea levels there are actually dropping. Solving mysteries like this or the Antarctica impact crater anomaly gives scientists amazing insights into the past of our planet. And by understanding how past changes in temperature and geology affected Earth, scientists can predict how today's human activity can impact our future.
Hey, quick question. How many continents are there? 7? Maybe 5? There's no correct answer. According to different approaches, the range is between 4 to 7. But it might actually be as many as 8. Chances are, a lost continent has recently been found between Greenland and Canada. This new continent discovery could also potentially be the key to how microcontinents form. What does this all mean, and what makes this hidden landmass near Greenland so important? Now, if you're like me, and if you are, then there's two of us, when you hear the word continent, you probably think of land like Europe or Africa, places above water where people live. But in science, a continent isn't about being above sea level. It's about what the land is made of. Earth's outer layer, called the crust, comes in two main types, continental and oceanic. Continental one is thicker, lighter, and made of different types of rock, like granite. The oceanic crust is thinner, heavier, and made mostly of dark volcanic rock. Now, the discovery under the Davis Strait between Greenland and Canada appears to be a piece of continental landmass, even though it's under the ocean. Scientists call it a proto-microcontinent because it began to break off from a larger terrain millions of years ago, but never quite made it. As tectonic plates slowly shifted, the Earth's crust in this region stretched and cracked. One chunk started to split away, but for some reason, the process stopped. It didn't drift off like a full continent, and it didn't sink like ocean crust either. Instead, it stayed right there, floating beneath the waves all this time. This makes it different from true microcontinents, like Zealandia, which have completely detached and now exist as separate tectonic blocks. Zealandia is a submerged microcontinent near New Zealand. About 94% of it lies underwater, but because it's made of continental crust, many geologists say it qualifies as Earth's eighth continent. However, Zealandia is still debated because it's too big to be a microcontinent, and there's no official global body to define its status. There's no global organization like the UN or some kind of international geology council that can declare, hey, this is a new continent. Unlike Madagascar, which is fully above sea level and widely accepted by geologists as a classic example of a microcontinent, Zealandia is still waiting for a proper label. I know you're probably wondering, isn't Madagascar an island? The simple answer is, it's both. It's the fourth largest island in the world completely surrounded by water, but it's also geologically considered a microcontinent because it broke off from the supercontinent Gondwana around 88 million years ago and is made of continental crust, not oceanic crust. Unlike volcanic islands like Hawaii, this isn't just built from lava. It's a real piece of ancient continental crust. So Madagascar checks both boxes: island by geography, microcontinent by geology. And that's exactly why these discoveries can be fascinating. Just like Madagascar stands out above the waves, this newly discovered landmass under the Davis Strait stands out beneath them, thanks to its unusual structure. What makes it stand out is its unusual thickness. Most of the ocean floor is thin, like metal. This is more like packed clay, layered with continental materials. Underneath this cozy comforter, scientists discovered some odd layers of rock, unusual because they're not where they should be. These layers act more like the materials found on continents rather than those typically seen on ocean floors. There are hints of granite-like formations and distinct magnetic properties, which suggest that this stuff is similar to what makes up dry land. The size is also remarkable. The proto-microcontinent is about 12 to 15 miles across, which makes it roughly the size of a mid-sized city, like Manhattan Island that's 6,500 feet underwater. The fact that it sits right under the Davis Strait, one of the widest ocean passages on Earth, makes it one of the largest submerged continental fragments we've found. According to researchers, this landmass began to form between 58 and 49 million years ago, when Greenland and Canada were slowly drifting apart. Maybe they just weren't getting along. Hey, it happens. As they pulled apart, the crust under the Davis Strait stretched, and one of the main fault lines shifted. But the breakup didn't finish. Around 48 million years ago, the rifting stalled and Greenland's motion away from Canada slowed dramatically when it later bumped into Ellesmere Island. It's like a car swerving off and then back onto the freeway, a turn that was never completed. That's basically what happened. A chunk of land got stuck between the motion. It didn't float off into the ocean like a new continent, and it didn't get pulled down into the Earth either. It just stayed where it was, stranded beneath the water. But that's not all. This chunk has its own fault system, and scientists say it actually looks like a miniature version of the San Andreas Fault in California. Now, a fault is basically a crack in the Earth's crust where sections of rock slide past each other. Think of it as a place where the Earth's surface split and tried to slide sideways. In California, this movement still happens today and can cause earthquakes. But under the Davis Strait, it's a different story. The movement started, then suddenly stopped, like hitting pause in the middle of a big shift. It's a frozen moment in the planet's past, preserved right beneath the waves. For geologists, that makes the microcontinent under Davis Strait incredibly valuable. That sudden pause in motion helps explain why some chunks of land break away cleanly, while others twist, stall, or disappear. But this isn't just academic. By studying how continents break apart or stall, scientists can better predict future shifts in land, fault lines, and seismic activity. And predicting earthquakes and geological hazards could prove quite valuable to everyone. Knowing how microcontinents form could help us anticipate how the planet's surface might shift over millions of years, which affects everything from climate models to resource availability. But even just the technological advancement needed for such discoveries is greatly beneficial. The same tools used to map this hidden land are used for oil exploration, laying undersea cables, climate monitoring, and even search and rescue missions. Speaking of technology, for a long time, this hidden landmass near Greenland remained invisible. Just 10 or 15 years ago, the ocean floor under the Davis Strait was basically a mystery. It's deep, almost frozen, obviously not the easiest place to explore. But today, thanks to modern tools, a new continent discovery could be just a matter of time. Scientists can finally see and hear what's going on under all that water. First, they use seismic reflection imaging. That's a method where ships send sound waves down to the ocean floor and record how they bounce back. Various layers of rock reflect sounds in different ways, which helps build a picture of what's hidden underneath. It's kind of like how bats use echoes to see in the dark. Satellites also play a role in collecting gravity data. This may sound strange, but different types of rocks have slightly different weights. Heavier rocks create stronger gravitational pull, and satellites can measure those tiny differences. Another tool commonly used for these explorations is underwater sensors, which sit quietly on the seafloor and listen for natural vibrations, like mini earthquakes or shifts in rock. These vibrations help scientists figure out what the crust is made of and how thick it is. They're basically ears on the ocean floor. They also most likely used AUVs, or autonomous underwater vehicles, basically robot submarines that can scan the seafloor in high resolution, even under thick ice. In any case, scientists are very excited because this new continent discovery is more than just a geological surprise. It's what they call a natural laboratory. The study of the microcontinent Davis Strait offers a rare opportunity to understand how microcontinents form, evolve, and sometimes fail to fully separate. It also reminds us that Earth's crust isn't as neatly divided as we once thought. Beneath the ocean, there may be other hidden landmasses near Greenland or elsewhere, almost continents just waiting to be found. This lost continent of Canada may not have made it as a fully fledged landmass, but its discovery is already reshaping how we view plate tectonics. And thanks to advances in technology, places we once ignored are now offering up secrets about the planet's deep past, and maybe even its future. New Zealand is located in the Southwest Pacific, and it isn't just a country of mountains, the world's quirkiest creatures, and hobbit holes. But here's another cool fact. New Zealand sits on top of a hidden continent that's 94% underwater. That's right, just the tip of a sunken landmass more than half the size of Australia. And with sea levels rising, one question keeps, surfacing. Is it possible that all these remarkable creatures will need swimming lessons one day? Zealandia is a sprawling, drowned continent stretching from New Zealand to New Caledonia. This underwater region has mountains, valleys, and its own geological personality. But wait, how can something underwater be called a continent? Well, it turns out being underwater doesn't disqualify you from being a continent. It just makes you harder to spot. Most people think of continents as giant land masses you can walk on. But geologists don't define continents by what's above water. They define them by what they're made of. You see, most of Earth's crust is oceanic, thin, dense, and made of basalt. However, continents sit on continental crust, which is thicker, lighter, and much older. That's the case with Zealandia. Even though it's mostly submerged, it's composed of the same kind of crust as Australia or South America. It has mountain ranges, sediment basins, fault lines, it's not your fault, and even fossils that prove it once had forests and land creatures. Zealandia was above sea level during the age of dinosaurs, and while we haven't found a raptor-like theropod skeleton yet, there's no reason to believe we won't. So how was this discovery made? Since most of Zealandia sits about 1/2 to 1.5 miles underwater, it wasn't easy. We can't drain the region like a bathtub just to take a look. So the answer had to be technology. Scientists used satellites to calculate tiny changes in Earth's gravity to spot what was hiding under the waves. Yep, fun fact, there are satellites that can measure gravity now. For example, NASA's mission GRACE has 2 satellites that find small changes in Earth's gravity. It does this by measuring how far apart the satellites are as they move over different things. Scientists also use sonar to map out the underwater mountains and valleys in 3D. Finally, deep ocean drilling pulled up ancient rock, soil, and even land-based fossils from beneath the seafloor. Physical proof that this wasn't just the ocean floor. Not that scientists use all this tech in that exact order, like following steps on a checklist. It actually took decades of overlapping data from land, sea, and space to connect the dots. By the early 2000s, enough evidence had piled up that some geologists began to speak openly about a possible hidden continent. Still, it wasn't until 2017 that Zealandia was formally proposed as one, backed by clear geological criteria. And in 2023, after decades of mapping and research, Zealandia became the first continent to be fully mapped while almost entirely underwater. But why did it sink in the first place? Long ago, all of Earth's land was joined in a single supercontinent called Pangaea. Around 200 million years ago, yeah, I wasn't around then, it began to split apart. The northern half became Laurasia, which included what is now North America, Europe, and most of Asia. The southern half became Gondwana, made up of present-day South America, Africa, Antarctica, Australia, India, and Zealandia. About 85 million years ago, Zealandia broke off from Gondwana. It used to be connected to Australia and Antarctica, but when it split, its crust became too thin and stretched out. That made it less sturdy and more prone to sinking. You can think of it like a piece of ice that floats lower in the water after it breaks off a bigger chunk. Over time, tectonic forces, like plate movement and the loss of its deeper support, caused most of it to sink. It didn't just sink because it was weak, but because it was pulled down by Earth's shifting plates. It settled lower into the mantle because it didn't have the structure to stay higher up. Today, only the highest ridges, like New Zealand, remain above water. That's kind of cool to think about. If Zealandia had never sunk, Wellington would be somewhere up to 9,800 feet high. That's higher than Aspen, Colorado. Now, we know New Zealand is packed with weird and wonderful animals, birds that can't fly, bugs that glow, sheep that outnumber people. But what about its underwater world? Is it just as special? Actually, yeah. And honestly, maybe even cooler. Zealandia's sunken edges are home to marine life that's just as unique and isolated as the wildlife on land. We're talking thousands of species that evolved in near total obscurity, tucked away on a submerged continental shelf. Think of it as Earth's secret underwater lab. This is all thanks to diverse temperatures and over 50 different habitats in coastal regions alone. Take fish, for example. Some are delicious. But around 300 species found in these waters are endemic, meaning if you don't live near New Zealand, you'll never see them. This cute little fish is called southern lemon sole, and it stands out with its asymmetrical, pancake-like body and the odd habit of burying itself almost completely in sand, leaving just its eyes poking out. And the deeper you go, the stranger it gets. Zealandia's underwater slopes and canyons have creatures that feel like they were designed during a power outage at the Evolution Lab. My favorite is carnivorous sponges. Yep, sponges that eat meat. There are also sea daisies, which are small, flat, round creatures that don't seem to fit neatly into any specific family of animals. Scientists have discovered these unique little animals hanging onto sunken wood more than half a mile deep in the ocean. They're so unusual that researchers almost created a separate category just for them in the echinoderm family tree, which includes other marine life like starfish and sea urchins. And then there's the New Zealand scamping, a lobster-like crustacean that lives in muddy burrows on the ocean floor. This creature snacks on jelly-like blobs, ghost sharks, and pretty much anything that floats by. Even seaweeds are unique there, although they're not as cool as predatory sponges. Oh, by the way, an interesting fact about the regions close to New Zealand is that they hide active underwater volcanoes. The most famous one is called Brothers Seamount. It's located about 210 miles northeast of New Zealand. It's a massive underwater volcano with a crater at the top, constantly bubbling with heat and chemicals. What makes it fascinating is that these vents, called black smokers, support ecosystems that don't rely on sunlight. Instead, bacteria use chemicals like sulfur to produce energy, a process called chemosynthesis. These bacteria form the base of a food chain that includes species like tube worms and deep-sea shrimp, which are adapted to survive in extreme heat, pressure, and complete darkness. That's not typical for most ocean life, which depends on photosynthesis and stable conditions. Brothers Seamount is also loaded with metals like copper and zinc, making it scientifically valuable and, potentially, commercially tempting. So it goes without saying that Zealandia is incredibly important to scientists. It offers a unique window into Earth's geological and biological history. It's like a time machine and a natural lab that helps scientists piece together Earth's history. So, in the end, could New Zealand end up underwater due to water levels rising naturally with each century? If you're imagining New Zealand slowly disappearing beneath the waves, like a real-life Atlantis myth, don't. Even with sea levels rising, that kind of full-on submersion just isn't likely, even in the worst-case scenario. New Zealand's tallest point, Mount Aoraki, stands over 12,000 feet above sea level. For the ocean to cover that, it would need to rise by more than 2 miles. And unless Earth suddenly turns into a water balloon, that's not happening. Okay, but what about sinking? Could it sink like Zealandia did? Zealandia sank because it had a thin, stretched-out crust. It didn't have the strength to stay up. But New Zealand? It's sitting on the sturdy, lifted backbone of the continent. In fact, thanks to tectonic plate collisions, parts of it are actually rising every year. And not just rising, shaking too. Zealandia has active tectonic plate boundaries, which is why the region gets so many earthquakes and volcanic events. So, while Zealandia may be almost entirely underwater, New Zealand is holding its ground, literally. In other words, the Kiwi won't need swimming lessons anytime soon. So, the distance from New York to Lisbon, on the other side of the Atlantic, is well over 3,000 miles. At the average walking speed for a human, you could trek there in a month and a half. That's not counting the rest stops and much-needed sleep. Buying an airline ticket or boarding a ship aren't just better options, but the only travel possibilities right now. But if this long journey on foot became possible one day, would you be up for the challenge? The most obvious obstacle is all that water in the Atlantic Ocean. It covers around a fifth of the Earth's surface. All the oceans take up around 70% of our planet. When you open the tap or buy a bottle, you are drinking a tiny percentage of potable water. 97% of Earth's water is located in oceans. It's all salt water, and it's not drinkable. Add this 2% of water trapped in glaciers and ice sheets, and you get less than 1% of water that we actually drink. When you put these percentages into numbers, you'll need a long sheet of paper to write them all down. The U.S. Geological Survey estimates that there are over 330 million cubic miles of water in the world. It's essential for sustaining all life forms, including humans. Oceans play a vital role in regulating air temperature around the globe. If they didn't have any water, the area around the equator would be scorched. This imaginary line that divides our planet in half runs through 13 countries in total, such as Brazil, Kenya, and Indonesia. The world's oceans are critical for our planet's water cycle. You know, like the one you learned about in school? It rains from the clouds and water eventually ends up in rivers that empty into the oceans. Then sunlight warms up this vast body of water, so it evaporates into the atmosphere to form new clouds. Then the cycle starts over. This process shapes the global climate. That's why, for example, the Mediterranean is so popular for the summer holidays. The region is temperate. If we take the oceans out of the equation, the water cycle stops. The area where they once sat would turn into a huge dust bowl. There would be dirt as far as the eye could see. Since there is no more evaporation, clouds won't form. Rain would become scarce. Humans would soon run out of sources of drinking water. The landscape of our planet would turn into a vast desert. Imagine a Sahara-like terrain stretching across the surface of our planet. Everything would become so dry that fires would break out easily. These are hardly the ideal conditions for a long trek between continents, but let's imagine you were able to survive all this. You start walking across the desert land that was once the Atlantic Ocean. What would that journey be like? You would encounter a landscape different from the one above the waterline. Everything below the waves is taller and deeper than the world we know. This is the land of extremes. Take, for example, the highest mountain on the planet. If you were thinking about the Himalayas and its tallest peak, Mount Everest, you are correct. Well, kind of. This mountain range is the highest when you measure it from the sea level, just above 29,000 feet in height. But when you measure the height of the mountain from its base to the peak, then the Himalayas drop to second place. The highest mountain on Earth is actually Mauna Kea in Hawaii. It's a dormant volcano. In the local language, its name translates as White Mountain. Nearly half of it lies under the waves of the Pacific Ocean. Its full height is close to a mile higher than Mount Everest, at 33,500 feet. We can't appreciate its scale right now, but if the Pacific dried up, we would be able to stand at the base of this giant. The bottom of the Atlantic hides a similar mountain range. It's the largest geological feature on the planet. We can't see it because the mid-Atlantic ridge is almost completely submerged. It rises from the ocean floor to a height half of that of Mount Kilimanjaro. The width of the massive underwater range reaches 1/10 of Earth's diameter. The only visible sections of the mid-Atlantic ridge are islands such as Iceland and the Azores. The remotest inhabited island in the world also belongs to the visible part of this geoformation. Perhaps the only thing more impressive than its size is the date of the discovery of its ridge. Scientists charted it out in the 1950s. That's pretty recent when you consider our civilization is thousands of years old. This shows how little we know about what's hiding under the surface of our oceans. UNESCO estimates that humans have explored only 5% of Earth's oceans. It seems hard to believe, but more people have been to the moon than at the bottom of the ocean. The deepest place on our planet lies in the Mariana Trench. The discovery of the Mid-Atlantic Ridge revealed the secret behind the formation of continents and oceans. When you know the truth behind their origins, you'll know what to expect on your imaginary trek across the Atlantic. The ridge sits right between North America and Europe. But you need to think of these landmasses not as continents, but as tectonic plates. These are huge chunks of Earth's outer layer. It's called a lithosphere, and is mostly comprised of rock. There are around 15 to 20 such ginormous plates on our planet. They float on a layer of partially molten rock. Well, they don't actually float, but that's the term scientists use to best describe their instability. Tectonic plates are constantly on the move. They can bump into each other. In this case, one plate goes down while the other one is lifted. This creates vast amounts of energy. On the surface, we get earthquakes and volcanoes. Tectonic forces gave our planet its familiar shape. That's how the Himalayas formed 40 to 50 million years ago. Around that time, the Indian plate shifted northward. It bumped into the southern part of the Eurasian plate. Since the two plates were composed of a similar type of rock, they each refused to go under the other. The only possible direction was up. This process is still not over. The range grows by 1/3 of an inch every year. A similar thing is happening with the Mid-Atlantic Ridge. It is widening at an annual rate of 1.5 inches. And there's an interesting side effect of this process. Do you remember the time when you were building sandcastles? In order to build the keep, you needed to dig up a lot of sand around it. As the castle grew in size, the hole around it became bigger. The same thing is happening in the Atlantic Ocean, but on a much larger scale. As the ridge is getting wider and wider, the two coasts are drifting away from each other. The North American plate and the Eurasian plate are moving apart. This means that your imaginary trip in a world without oceans might take longer. For every year you wait, you'll need to cover an extra inch. Now, that doesn't seem like much today, but give it some time and you might not have to embark on a cross-continental journey after all. The continents will come to you. Now, evaporation is not the only way to drain an ocean. The coast on each side of an ocean might simply close in on it. This is what scientists believe will happen to the Pacific. Some 50 million years from now, give or take, you wouldn't be able to recognize the Earth's largest ocean. Experts ran a series of computer simulations to see where North and South America are headed. The answer is to the North Pole. This is where they'll merge with Asia in the distant future. The new supercontinent will completely change the shape and size of the Pacific Ocean. Geologists have a name ready for this landmass: Amasia. Now, history teaches us that the supercontinent existed a long time ago, around 300 to 273 million years back. At that time, all the continents on Earth were buddies and hanging out together. They formed an amazing crew called Pangaea, or Pangaea if you're feeling fancy. The name comes from a Greek word which means all the earth. Pangaea also had a massive water neighbor called Panthalassa. So our entire world was a huge piece of land surrounded by a huge piece of ocean. The megacontinent looked like a giant sea, stretching between the tippy top and bottom of our planet. But as stories go, things change. About 200 million years ago, in the early Jurassic epoch, like dinosaur times, Pangaea decided to throw a breakaway party. Forget about the old ideas of continents just drifting around like big icebergs. It split up into smaller chunks, forming the continents we know today. Oh, and it created the Atlantic and Indian Oceans as a bonus. Pangaea's tale was first told by a German weather expert named Alfred Wegener in 1912. But how did he learn about something that happened so long ago? Imagine the Earth's core as a big, cozy fireplace, giving off heat. This heat creates special swirling currents in the Earth's outer shell. We can think of it as the Earth's crust, which looks like a big puzzle with many puzzle pieces. The hot currents make these puzzle pieces, called crustal plates, move around. Sometimes they push apart, sometimes they crash into each other, and sometimes they slide past one another. It's like a fantastic dance party that goes on beneath our feet. One day, Wegener looked at the shapes of the continents and thought that, hey, those coastlines of South America and Africa kind of fit together. And they really did. So he imagined that way back, all of the continents hung out together as one big landmass. But he couldn't just go and say that without any proof. So how do we know Pangaea really was a thing? Well, there are some clues that brought us to this amazing discovery. One clue is like when you put a puzzle together and the pieces fit just right. Take a look at the shapes of today's continents. You'll notice that they could fit together almost like a perfect match. Obviously, their shapes changed over time. It happened millions of years ago, and since then, the shores of continents have been washed by waters for years. But even so, we can still see how well they fit together. Another clue comes from checking out fossils. We know that ancient animals left a lot of fossils behind. That's how we learn their history and what species there were. But when scientists compared fossils found on different continents, they found something interesting. These fossils look similar. Surprisingly, they belong to the same groups of animals, even though they were far apart. It's not like these animals could swim across the ocean on their four paws. And it's unlikely that this particular type of animal originated in two places at the same time. And finally, the mountains. Imagine exploring underwater and finding huge mountains in the oceans. These underwater ranges and deep trenches are like scars from when Earth's tectonic plates moved around. They serve as another proof that the continents are part of something bigger. When you look at these things together, you get a pretty clear picture. The Earth's continents were once huddled together in the supercontinent. They've since gone their separate ways, but the memories of their grand adventure are still written in the shapes of coastlines, the rocks they left behind, and many more. But it's obvious to us now. At the time of Wegener's discovery, there were different ideas flying around. Some folks thought that the continents sank down to make the oceans, but Wegener had a different take. He thought that the continents are always on the move. He even came up with a fancy phrase, continental drift, to explain it. Later, he was joined by another scientist named Alexander du Toit. He added a little twist to the story, suggesting there were two original continents, Laurasia in the north and Gondwana in the south. But the real party didn't start until the 1960s, when scientists figure out the secret ingredient in this recipe, plate tectonics. And finally, this theory explained everything Wegener and du Toit talked about. Wegener's theory was proven correct after 50 years. As time passed, we learned more and more about our planet. We found out that the Earth used to have multiple supercontinents. Before Pangaea, there was a megacontinent called Rodinia around 1 billion years ago. And later on, Pannotia joined the scene about 600 million years ago. What's interesting is that the continental drift story is far from over. Our continents are always on the move. Africa is giving Europe a friendly bump, and Australia is playing a game of bumper cars with Southeast Asia. You know what's on the horizon? Another supercontinent. So, how will this next supercontinent come together? Well, there are 4 major possibilities: Novo Pangaea, Pangaea Ultima, Orica, and Amasia. These might sound like superhero names, but they're actually ways the puzzle pieces could fit. Let's look at them all. First, Novo Pangaea. You know how there's the Atlantic Ocean on one side and the Pacific Ocean on the other? Well, if these oceans keep doing what they're doing now, the Atlantic will keep opening up while the Pacific squeezes in. If that happens, the Americas, North and South America, will give each other a big high five. And Antarctica, that icy land way down south, will join the fun too. It'll be drifting northward. Next, Pangaea Ultima. In the future, the Atlantic Ocean might get tired of being so wide. It might decide to slow down and shrink a bit. The Americas and the northward drifting Antarctica will probably crash into Africa and Europe. And just like that, a brand new supercontinent forms. There are these spots where the ocean floor is sliding underneath the land. It's like a secret underwater passage. These spots are called subduction zones. So if these secret tunnels will be spreading and spreading all along the east coast of the Americas. The Americas, Europe, and Africa might come together again, and they'd form a supercontinent. This supercontinent would be surrounded by the Pacific Ocean. The next possible supercontinent is Orica. In this scenario, the Pacific and Atlantic Oceans might decide to take a nap and close up. But don't worry, because when one door closes, another opens. In this case, a whole new ocean would pop up to replace them. Imagine a big crack in the ground cutting through Asia, like a zipper opening up. This crack is called the Pan-Asian Rift, and it would become a brand new ocean. With this new ocean comes a new supercontinent, Orica. Australia is currently drifting northwards, like it's trying to find a nice spot at the center of our planet. East Asia and the Americas might join in from both sides. After that, Europe and Africa might link up with the Americas, and boom, Orica. And finally, Amasia. It might form if some of the tectonic plates go north. They can take continents like Africa and Australia along for the ride. They'll be hanging out around the North Pole. All the continents except Antarctica might come together. And even though they might gather around the North Pole, they won't close off the oceans. The Atlantic and Pacific Oceans would still be open for business. How this grand reunion happens depends on the Earth's tectonic movements. So far, we believe that Novo Pangea is the most likely scenario. It also depends on what exactly happened to Pangea after it broke apart. And when the new supercontinent appears, what's going to happen with the weather? How will the ocean behave? And what about the animals and plants? These questions all light up our minds. Who knows? Maybe someday our descendants will look at the world map and see this incredible journey come full circle. So keep asking curious questions and stay tuned for the next 100 million years.
About 2 billion years ago, a massive asteroid crashed into Earth, leaving behind total destruction and what we now call the redraw crater in South Africa. And get this space invader might have been way bigger than scientists originally thought, possibly twice the size of the asteroid that wiped out the dinosaurs. Nowadays, the redraw crater is about 99 miles across, which makes it the biggest visible crater on Earth. But technically, it's still smaller than the Chicxulub crater in Mexico. The latter is about 112 miles, and it was left by the infamous dinosaur distractor 66 million years ago. But the thing is, craters don't stay the same forever. Over time, erosion wears them down. That's why they start looking smaller than they used to. And scientists think that when the redraw crater first formed, it could actually reach 174 miles across. That means it was the biggest impact site Earth has ever seen, even though it looks smaller today. Just imagine how insane that impact must have been. A space rock that would have sent shockwaves ripping across the planet, triggered enormous wildfires, and completely changed the climate. The asteroid likely hit Earth at a very, very high speed. But since this catastrophe happened billions of years ago, way before dinosaurs or even complex life saw the light of day, it didn't wipe anything out like the Chicxulub asteroid did. At the same time, recently, researchers have realized that the asteroid might have been even bigger than they thought previously, up to 15.5 miles wide. As for the speed at which it slammed into Earth, it could reach a staggering 56,000 miles per hour. Now, figuring out how big redraw originally was, that's been a bit of a headache. The main issue is that it's super old, and we're talking about 2 billion years old. No wonder that over that much time, erosion has kind of worn it down. So it's hard to tell just how huge it once was. But it's not just erosion causing the problem. Over the years, new layers of rock have built up over parts of the crater, and they've covered up most of the original structure. That's why now only little pieces of the raised rim are left, and this makes it even harder to get a clear idea of how big it was. So, scientists started looking at the minerals around the crater, like quartz and zircon. They discovered that those were all messed up by the asteroid's impact. They had tiny fractures caused by the blast. Researchers studied those damaged crystals and managed to figure out how far the explosion actually spread. Equipped by this new knowledge, scientists now believe that their latest estimates of the size of the asteroid are the most accurate ones. The reason why we haven't heard much about this disastrous impact is that, unlike the Chicxulub asteroid, which wiped out the dinosaurs and reshaped life on Earth, the redraw asteroid hit at a time when Earth was a very different place. There were no trees, no animals, just single-celled life in the oceans. That means no mass extinction, no burning forests, no fossilized evidence of chaos. But scientists think it still had a massive impact on the planet. It might have changed the climate even more dramatically than the asteroid that ended dinosaurs. But since we don't have much direct evidence of the disaster, studying what's left of the Vredefort crater is one of the only ways to understand just how powerful this impact was. Even though it happened billions of years ago, learning about this impact can help us understand the history of our planet, and maybe even prepare for future asteroid threats. After all, they could be similar to what happened in Siberia at the beginning of the 20th century, pretty recently. It was a warm morning, June 30th, 1908, when the sky suddenly lit up with a blinding flash. What followed was an explosion so powerful that it remained a mystery for decades. Known as the Tunguska event, it was one of the most baffling disasters in history. Scientists suspected an asteroid impact, similar to the one that wiped out the dinosaurs. But there was one eerie problem. No crater was ever found. The explosion struck deep in the remote forests of Siberia, near the Podkamenaya Tunguska River. The blast was beyond anything seen before, flattening around 80 million trees across an area of 830 square miles. The sheer force of the event was mind-boggling. It was strong enough to devastate the landscape, scorch the ground, and wipe out countless animals. According to witnesses, there was an eerie glow in the sky, which was followed by a streaking fireball with an intense bluish light. It was brighter than the sun. Moments later, there was a deafening blast. The shockwave was so powerful that it shattered windows hundreds of miles away, and people were knocked off their feet. Yet, despite the destruction, the source of the explosion left no obvious trace. Later, scientists finally started to understand what had occurred on that day. Imagine a meteoroid racing into Earth's atmosphere, transforming into a blazing meteor. It's traveling so fast that the air in front of it compresses and heats up, setting it on fire. But it's so large that it doesn't just burn up all of a sudden, it explodes. When that happens, the blast releases so much energy that a powerful shockwave spreads out. And since the explosion happens in the air, it leaves no impact crater. Back in the early 1900s, with limited technology and the remote location, scientists were left with a puzzle. Only much later did they eventually conclude it had been an airburst, where an object explodes high in the atmosphere, never striking the ground but releasing enough energy to devastate the area. Most likely, it was a giant asteroid about the size of a 25-story building. It could have been moving at around 33,500 miles per hour and exploding about 3 to 6 miles above Earth's surface. Another wild story happened back in the late 90s, but it wasn't Earth that was affected. A comet got stuck in orbit around Jupiter. One day, it got too close, and Jupiter's immense gravity broke it apart, turning it into a bunch of pieces. Some of them were as big as half a mile across. Scientists were curious because they didn't know what would happen when those pieces hit the planet. And in July 1994, the moment came. The comet's broken up pieces started crashing into Jupiter, one after the other. Over 6 days, 21 chunks of the comet smashed into the planet at insane speeds, like 37 miles per second. That's more than 130,000 miles per hour. The impacts were so powerful that they heated up Jupiter's atmosphere to a mind-boggling 53,000 degrees Fahrenheit, which is way hotter than the sun's surface. When each chunk hit, it sent massive plumes of material flying out of Jupiter, like when you throw a rock into a pond, but way bigger. Some of these plumes shot up almost 1,900 miles into the sky. Afterward, big dark scars appeared in Jupiter's atmosphere, and they stayed visible for months as the debris spread out across the planet. But this wasn't just a cool space event. Scientists actually learned a lot from it. Those dark impact marks helped scientists track the winds in Jupiter's stratosphere. The crashes even caused temporary changes in Jupiter's glowing auroras, showing that the planet's magnetic field was affected by particles from the explosions. Plus, the comet fragments didn't just make a mess, they also left behind new chemicals in Jupiter's atmosphere. Plus, some chemicals were also exhumed from the lower atmosphere. Some molecules like ammonia broke down over time, but others, like hydrogen cyanide and water, are still floating around Jupiter today. This helped scientists understand how different chemicals react and mix in Jupiter's atmosphere. Comet Shoemaker-Levy 9 was a wake-up call. It proved that massive space collisions still happen in our solar system. That's one big reason why NASA started looking into how we can track and prepare for any future impacts that might threaten Earth. Whether it's learning more about asteroids and comets, or about how giant impacts shape planets, the importance of such discoveries is undeniable. Scientists discovered the largest water reservoir in the Oregon Cascades. It's hiding underground, holding more than twice the water volume of Lake Mead. Let me specify. It contains at least 19.4 cubic miles of water, which is almost 162 trillion bottles of water. If you drank one bottle a day, it would take you around 444 billion years to finish your stock. No wonder this underground aquifer discovery is so awesome. The Cascade Mountain Range, which contains the largest aquifer on Earth, stretches about 700 miles from Northern California to British Columbia. The high Cascades in Oregon have younger volcanic rocks, around 8 million years old. The Western Cascades are much older, 45 million years. They boast deep canyons and valleys. Scientists study the transition zone between these two areas to understand how water moved through volcanic rock and how volcanic processes had evolved over time. In the process, researchers measured rock temperatures at different depths. That's when the underground aquifer discovery happened. Normally, deeper rocks should be hotter because it's closer to the Earth's interior. But to everyone's surprise, in several areas, the temperature stayed the same even at greater depths. Well, this was a strong clue that water was flowing through the rock and cooling it down. In other words, the Cascades function like a natural water tower, storing and slowly releasing water into rivers and streams. These geological water findings are important for two main reasons. First, it's our potential water source for the future. Such a massive amount of water stored underground could be an important resource. So far, we don't know how long it will remain in its current state and how resilient it's going to be to changes. So, we need more research to properly manage its use. Secondly, it affects volcanic activity. When water seeps deep underground and reaches magma, it instantly turns into steam, creating extreme pressure that can trigger explosive volcanic eruptions. Understanding how much water is stored in volcanic rock could help predict future eruptions and the risks they pose. Now, even though this discovery is exciting, there are still many unanswered questions. Like, how does this water move through the volcanic rock? Or how much of it is actually usable as a water resource? Since this underground reservoir depends on rain and snow, a series of dry years could cause big problems for both water supply and volcanic stability. Researchers are now working to understand the full impact of the Cascades volcanic water reservoir and how to manage it responsibly. But let's look closely at the geological wonder that is the Cascade Range. Picture this: a massive mountain range stretching all the way from Northern California up to British Columbia, cutting right through the middle of Oregon. That's the mountain range we're talking about. In Oregon alone, it's about 260 miles long and up to 90 miles wide, covering 17,000 square miles. Whoa, that's bigger than each of the 9 smallest US states. The coolest thing is that the Oregon part of this mountain range is basically built by volcanoes, and apparently contains at least one volcanic rock water storage. The range itself exists because of something called the Cascadia Subduction Zone, where the Juan de Fuca tectonic plate, a chunk of Earth's crust under the Pacific Ocean, is slowly getting shoved beneath North America. As it sinks, the intense heat and pressure force water out of the oceanic rock. It lowers the melting point of the surrounding mantle and creates magma. That magma rises up and fuels the Cascade volcanoes. This is part of the Ring of Fire, the giant belt of volcanoes circling the Pacific. So, in a way, the Cascades are part of a much bigger volcanic system that's constantly shifting and changing. The Oregon Cascades are actually made up of two completely different zones, the Western Cascades and the High Cascades, and they look nothing alike. The Western Cascades are the older part. They formed around 45 million years ago. These mountains are rugged and deeply carved up by rivers. Some canyons are as deep as 3,700 feet. This part of the range used to be volcanically active, but over time, erosion has taken over, reshaping the land. The High Cascades, on the other hand, are much younger and way less eroded. Around 8 million years ago, the volcanic activity shifted, and new eruptions filled in old canyons, smoothing out the landscape. Eruptions kept piling up fresh lava, and rivers in this region didn't have as much time to create deep valleys like they did in the Western Cascades. That's why if you look at the two regions side by side, one looks jagged and carved up, while the other looks smoother and more built up. Some of Oregon's most famous volcanoes are located in the High Cascades. I'm talking about Mount Hood, Mount Jefferson, the Three Sisters, and Crater Lake, which actually formed when Mount Mazama erupted and collapsed in on itself. Unlike smaller volcanoes that pop up, erupt for a bit, and disappear over a few months or years, these giant volcanic centers have been active for thousands of years. And because they've been around for so long, they have way more complex magma systems. They produce everything from basalt, which is a runny, fast-moving lava, to andesite, dacite, and rhyolite. And rhyolite is the type of magma that leads to huge explosive eruptions. So while some of these volcanoes might just ooze lava, others have the potential for devastating blasts. Another amazing thing about these long-lived volcanoes is that their underground magma chambers stay hot for a really long time. That's why the Cascades are one of the best places to tap into geothermal energy. There's a ton of heat just sitting beneath the surface, waiting to be used. Oh, and don't forget about the Cascades volcanic water reservoir. Who knows how we will use it in the future? Now, we already know that the Cascades are part of the magnificent Ring of Fire, Earth's most explosive zone. Imagine a massive horseshoe-shaped belt wrapping around the Pacific Ocean, stretching for about 25,000 miles. It's one of the most geologically active areas on the planet. This is where Earth's tectonic plates are constantly shifting, colliding, and grinding against each other, creating some of the world's most powerful earthquakes, volcanic eruptions, and deep ocean trenches. The Ring of Fire follows the meeting points of multiple tectonic plates, and they all surround the giant Pacific Plate. These plates aren't just sitting still, they're always on the move, pushing against or sliding beneath each other at their boundaries, known as fault lines. When this happens, you get everything from deep-sea trenches to towering volcanoes and violent earthquakes. One of the most extreme examples of this activity is the Mariana Trench, located east of Guam. At 7 miles deep, it's the deepest ocean trench on Earth. It was formed by a process called subduction, where one tectonic plate is forced beneath another, sinking deep into the Earth's mantle. The Mariana Trench is one of the most mysterious places on Earth. It's insanely deep, with crushing pressure and total darkness. So for a long time, people thought nothing could live down there. But it turned out that life existed even at the very bottom. In 2005, scientists found a tiny single-celled organism in the Challenger Deep, the deepest part of the Mariana Trench. They also came across colorful rocky formations and weird sea cucumbers. The Mariana Trench also has hydrothermal vents, which are basically underwater hot springs. Even though the water there is super hot and acidic, strange creatures and microscopic life forms still manage to survive there. The Ring of Fire is also responsible for 90% of the world's earthquakes. Some of the most powerful quakes in history have happened here, including the 1960 Valdivia earthquake in Chile, the strongest ever recorded, which hit a mind-boggling 9.5 on the Richter scale. But it's not just about earthquakes. The Ring of Fire is also home to about 75% of the planet's volcanoes. Some of the most famous eruptions in history have come from this region, like the infamous Mount Tambora in Indonesia. In short, the Ring of Fire is one of the most dangerous places on Earth, but it's also incredibly fascinating. Who knows what else scientists might discover in that region, like they discovered the largest water reservoir in the Cascades.
So hey, take a look. This is our planet's crust, its outermost and thinnest layer. And here's the mantle. It's way thicker. And this is the core. Wait, what's happening here? Uh-oh. The core is leaking right into the mantle. Quickly, we gotta stop the leak. What do you mean it's been going on for millennia? Earth's core is actually a very intriguing thing overall. Its unique properties, ranging from housing a mysterious metal orb to being nearly as hot as the sun's surface. Well, another one on this list of enigmas, apparently, our planet's core is leaking gas. I can relate. Is it dangerous for us? Is it going to boom if somebody lights a match? Well, not really, all because this gas is a rare isotope called helium-3. Helium-3 is a version of helium with one neutron instead of the usual two. Most of helium-3 in the universe was created around the time of the Big Bang, so it's some pretty ancient stuff. As the solar system formed, this gas became trapped deep within Earth's core. Shielded from space collisions and other cosmic hullabaloo, it remained hidden in the planet's depths for billions of years. Now, we've known for quite some time that occasionally, trace amounts of helium-3 escape to the surface, but no one has known the exact mechanism behind this leakage. Until recently, the breakthrough came with the discovery of exceptionally high ratios of helium-3 and its more common counterpart helium-4 in ancient lava flows on Baffin Island. This island is located in Canada's remote Arctic archipelago. The craziest thing is that these findings have the highest helium-3 ratios ever observed on dry land. The research revealed significant helium-3 levels. It might mean that the volatile elements from the solar nebula, that's the cloud of gas and dust that gave birth to our solar system, have remained in Earth's mantle since the earliest stages of the planet's formation. The discovery was made in lava flows that erupted around 60 million years ago, during the formation of a new seafloor when Greenland and North America split apart. But hey, it was amicable. The research team, led by Forrest Horton from the Woods Hole Oceanographic Institution, used advanced techniques to measure the helium trapped in olivine crystals within the rocks. These crystals formed before the magma erupted, which helped preserve the helium as it rose from deep inside the planet. The scientists found about 10 million helium-3 atoms per gram of olivine. That's a shockingly high concentration for Earth. You see, Earth's core acts as a reservoir for helium-3, storing it since the planet's formation. Over time, small amounts of this gas escape into the mantle through processes like mantle convection. That's when the planet's rocky interior stirs and moves like boiling water. Magma plumes, which appear in the mantle and rise to the surface, carry helium-3 with them. When the magma erupts, most of the helium escapes into the atmosphere. However, some of it gets trapped in crystals within the lava. That's how scientists can later study its origin and movement. Now let's follow the journey of helium-3 in the Baffin Island rocks. It began at least 100 million years ago. Mantle plumes carrying the helium likely took tens of millions of years to reach the surface. It means helium-3 has been leaking from Earth's core for millennia. It also means that our planet most likely formed in a solar nebula containing helium-3 and other noble gases. Baffin Island is an ideal location for studying Earth's deep interior. Its volcanic rocks are remnants of ancient lava flows that erupted when the North Atlantic began to open. The researchers traveled by helicopter to the remote island, which boasts towering cliffs, icebergs, and even polar bears. Local organizations helped the team access the area and ensured their safety during the expedition. The discovery of helium-3 leaking from the core raises new questions about what other elements might be stored deep within Earth. Could it be significant amounts of other light elements, such as carbon and hydrogen? These elements are critical for life and could provide further insights into the planet's habitability and evolution. For instance, the core's lighter-than-expected density might be explained by the presence of these elements. Plus, understanding the movement of helium-3 could also help track the behavior of other gases across the core mantle boundary. But this isn't the only unexpected discovery about Earth's insides. Let's go to Turkey's Central Anatolian Plateau. There, Earth's crust seems to be slowly dripping into the planet's interior. This process, known as lithospheric dripping, is still shaping the surface geology of the region. Lithospheric dripping occurs when the lower part of Earth's crust, heated to a certain temperature, becomes viscous and begins to flow downward. Imagine a thick liquid like honey or syrup flowing into a bowl. Now you get it. Now, speaking of Earth, it's been happening over a long period of time. And as this material moves downward, it pulls the crust with it, causing the surface to sink. As a result, we see new depressions or basins. Once this gooey material detaches from the crust and sinks further into the mantle, the surface rebounds, causing the ground to rise. This cycle of sinking and rising is what creates the shifting landscape in regions like the Konya Basin in the Central Anatolian Plateau. It is the very site where geophysicists observe signs of lithospheric dripping. The research team, led by Julia Anderson from the University of Toronto, first noticed unusual patterns in satellite data, including a circular feature in the region where the ground was sinking. After examining geophysical data beneath the surface, the team identified a seismic anomaly in the upper mantle and discovered a thickened crust beneath the Konya Basin. All this points to the presence of dense material, like a result of lithospheric dripping. The team's model suggests that the Konya Basin is currently in the later stages of this process. While the surrounding Central Anatolian Plateau has been uplifting over the past 10 million years, the Konya Basin is sinking at a rate of about an inch per year. While this number might seem small, it is quite significant in a region that is otherwise rising. Earlier studies have shown that the Central Anatolian Plateau has risen for around a half-mile over the last 10 million years. It likely happened due to lithospheric dripping. However, the discovery of the Konya Basin reveals that this process is not one time, but can occur multiple times in different regions. The initial drip that formed the Central Anatolian Plateau likely caused daughter events, which led to the formation of the Konya Basin. To validate their model, the researchers conducted a cool lab experiment. It simulated the lithospheric drip process. So, they took a tank filled with a highly viscous silicone polymer, which acted as a proxy for Earth's lower mantle. They also used a mixture of modeling clay for the upper mantle and ceramic spheres and silica sand to simulate the crust. A dense seed was inserted into the upper mantle layer to initiate the drip. Over the next few days, the researchers observed that the drip descended slowly. Within 10 hours, it began to fall. By 50 hours, a secondary drip had started. The results confirmed that, even without horizontal movement in the crust, the dripping process caused the surface to sink, forming a depression similar to the Konya Basin. This experiment has shown that lithospheric dripping can cause vertical deformations even without horizontal movements. Plus, it has proven that one event can trigger more drips that can change Earth's surface. This discovery helps scientists better understand how Earth's crust behaves over long periods of time and how tectonic processes can affect the landscape. Now, how about a bonus fact? In 1692, Edmund Halley, that guy famous for Halley's Comet, suggested that Earth might be hollow. He imagined layers beneath the crust with two concentric shells and a core about the size of Mercury, all floating in glowing gas. He even went further, speculating that these inner layers could be inhabited. This wild idea inspired Jules Verne's famous novel, Journey to the Center of the Earth. Wow!
This whole part of our planet has disappeared. It used to be a tectonic plate, but something that big doesn't just vanish without a trace. And the clues that led to its discovery started in this mysterious gap between South China and the island called Borneo. For a long time, people thought the sea between these two places sat on a tectonic plate called Izanagi, which no longer exists. But wait, how does a tectonic plate just vanish like that? Alright, tectonic plates are like pieces of a puzzle all connected together. But instead of sitting on a table, they're floating on this semi-fluid layer. So they're always shifting and bumping into each other. And there's something else. Some pieces of this puzzle are heavier than others. And what happens is that eventually, a heavier piece slips under a lighter one. Something similar happens with tectonic plates, but it's less about weight and more about density. When the edge of one plate sinks below another and gets pushed down into the mantle, that process is called subduction. But it's not just the edge that can sink. Entire massive plates from the past have completely vanished into the Earth's mantle. That's exactly what happened to the Izanagi plate. About 130 million years ago, it started sliding under the Okhotsk plate, getting swallowed little by little. By around 55 million years ago, it was completely subducted and replaced by the Pacific plate. And for years, specialists thought that the ocean between China and Borneo was sitting on that plate before it disappeared. Cool, but the experts got it wrong. Turns out the ocean between these lands wasn't sitting on the Izanagi plate after all. Instead, it fits into this weird, unexplained gap, as if a piece of the puzzle was missing. Recently, researchers at Utrecht University finally discovered that this gap was actually a ghost tectonic plate that no one knew about, the Pontus plate. It got its name because back when it existed, it sat beneath the ancient Pontus Ocean. But if it vanished so long ago, how did experts find it, right? Luckily, tectonic plates sometimes leave traces before they completely disappear. But instead of investigating footprints or fingerprints, it's more about looking for rocks. Yeah, stones from a lost plate can get incorporated into mountain ranges and show us where those ancient earth layers were. That's because rocks have a special power to record Earth's magnetic field. You know, that invisible shield that protects our planet from space threats, like solar wind and cosmic rays? So, as rocks cool and solidify, the magnetic materials in them, like magnetite or hematite, line up with Earth's magnetic field at the time and get locked in. They can freeze a record of the magnetic's field direction and strength. And since it changes depending on latitude, basically whether it's further north or south on the planet, it allows the rocks to kind of take a snapshot of their ancient position relative to the equator. Knowing this, researchers traveled to Borneo to collect and study the rocks over there. And they discovered something odd. These stones were originally from a much farther north region. Their ancient coordinates didn't match the latitude they expected for Izanagi. In fact, they didn't match any of the tectonic plates we knew about up until then. So they quickly realized two things. One, they had just discovered an eerie gap. Two, there must be a hidden ghost tectonic plate that used to be in that spot. To unravel the mystery, scientists used computer models to study the region's geology over the last 160 million years. Thanks to this technology, they were able to piece together the entire Pontus plate in all its glory. The next step was to figure out the key features of this part of our planet that had been submerged, like its age. You see, the rock samples collected in Borneo date back 135 million years, back when dinosaurs ruled the Earth. With this information, scientists realized that the Pontus plate was formed at least 160 million years ago, but it's probably even older than that. Although it is hard to pin down exactly when it was formed, one thing we can say for sure: it was huge, the Pontus Plate was about 1/4 the size of the Pacific Ocean. Unfortunately, by around 20 million years ago, it said bye-bye to the planet, sinking and being completely pushed under the Australian Plate to the south and China to the north. At this point, you might be wondering if a couple of rocks and a computer reconstruction are enough to prove that the Pontus Plate really existed. Well, yeah, they are. But other clues have also been found in Palawan, an island in the western Philippines and in the South China Sea. The truth is that the scientific community has suspected the existence of Pontus for over 10 years. At that time, researchers were really focused on the area around the Philippines. This region is like a playground for geologists, since it sits at the crossroads of several tectonic plate systems. So, scientists decided to reconstruct the movements of the Earth's crust between Japan and New Zealand. And because of that, the study suggested there had to be a subduction zone running through there, separating the known Pacific plates in the east from the hypothetical Pontus Plate in the west. These previous predictions were possible because tectonic plates are really bad at playing hide-and-seek. Like we said before they get submerged, they leave clues behind. And it's not just rocks. They can also change the Earth's mantle, which leads to the formation of volcanoes, earthquakes, and deep ocean trenches, for example. But the subduction process can also mess with the composition and temperature of the mantle, making some areas hotter or cooler. These are considered anomalies. It is possible to detect these anomalies using seismographs, which are instruments that pick up earthquake signals and record the ground's motion. When earthquakes happen, they send out ripples or waves through the Earth. These waves travel through the Earth's layers, but if they hit something unusual like an ancient piece of a tectonic plate hidden in the mantle, the waves get disrupted. It's like hitting a bump on a smooth road. It messes with the ride. Using regular seismometers to look for anomalies is fine, and it can totally help us find clues about the Earth's past. But if scientists want to use this method to get pictures of what's really going on beneath the surface, it gets a lot trickier. Not only do the images come out in low resolution, but the process also becomes insanely expensive. So recently, experts just uncovered a cutting-edge technique that could completely change the way we look at the Earth's depths. Kind of like an ultrasound, scientists can now actually see what's happening miles beneath our feet. More specifically, in a region between the Earth's brittle crust and the mantle underneath, known as the MOHO. This new method is called Distributed Acoustic Sensing, or DAS. It uses fiber optic cables, the same ones that give us high-speed internet, as earthquake sensors. Here's how it works. Laser beams are sent through the cables, and when the ground moves, whether from an earthquake, traffic, or other vibrations, the shaking changes how the laser light bounces around inside the cables. The cool part is that we can now measure these changes all along the length of the cable, so the cable ends up acting like hundreds of tiny earthquake detectors spread out over a huge area. This new tech can tell us things like whether major faults go all the way into the mantle, how ancient and modern processes have shaped the continents, and how strong the deep crust is in certain areas. In other words, DAS could be a game-changing instrument to help us uncover new clues about hidden and ancient tectonic plates.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.